Good morning, everyone. Good morning. Please take your seats so that we can start with our day. Okay, good morning once again, and welcome to our event, VEDECOM's conference. To officially start our day, I'm pleased to introduce Eric Lebeau, the General Director of VEDECOM, who will give us insights about the mission and activities of VEDECOM. Eric, the floor is yours.
Thank you, Hussein. So good morning, everyone. I'm very pleased to see so many people today and to welcome you on site. And also, I think we have some people on live stream, so I welcome them also, of course. It's a pleasure for us to have this conference. It's coupled with the Testival Festival that we host in our premises today and the 2 days to come also. So we are very happy to see the diversity of this ecosystem of e-mobility that is growing. We have here industry leaders, we have researchers, we have innovators, we have policymakers, and it's a growing ecosystem that we can see. VEDECOM has been hosting the Testival event in 2017 for the first time. And all we can say is that today there is more EV cars. There is even trucks, electric trucks, which we didn't have at the time. There are more players, and of course there is more complexity in all that stuff. And at VEDECOM we have the specialty as a research institute. We have both the technical side and the social and human factor side. And we think it's very important that we combine those two factors, because as we move towards intelligence services, we will need to take more the user into consideration, and because of course the user experience is key in the success of service implementation. And this is one of the reasons why we support this topic. We have today a very rich program. We will have keynotes, enlightening keynotes to make us think and forward think, see what is coming in front with challenges and opportunities in that environment. We will have also some roundtables in order to deepen our understanding of the current landscape. And also we will have, as you can see, there are some physical objects. We will have some demonstration and showcases to see the progress that have been made in the last years. So it's very important for us to have you here and to share all this with you. In VEDECOM, we have three main pillars, in fact, in our research. We work on electromobility, and this is what gathers us today. We have also we accompany everything related to the automated vehicle implementation. So we work less inside the vehicle, but more on how to have this new automated mobility in the streets and all connectivities with the infrastructure. And we also work on new ways of mobilities including small vehicles, and maybe those small vehicles, what we call light electric vehicles, maybe they will be also one day one of the subject of interoperability and charging, because they will be all electric also. And today it's not on the topic, but maybe one day it will become one. We'll see. And anyway, we work on this topic also. Our moderator today will be Hussein Halaj Hassan, who already opened this session. And he will guide you today all along the different topics. And I will lead the hand to him in order to guide you. And I hope that you will have a very inspiring conference. And for those who are also at the festival, I don't know how you will do it, but things are happening at both sides at the same time, so it's kind of exciting.
Thank you, Eric. So regarding the program, I'll not be presenting it as you received this by email in order not to lose time and focus on our discussions. At VEDECOM, and to help advance the e-mobility, VEDECOM has been leading an initiative called Mobena. And this initiative is one of the most important, especially at national and international level. And to know more about it, I'm pleased to introduce Murad Tegersha, who is the head of the electrification department at VEDECOM. Please, Murad, the floor is yours.
Thank you, Hussein. Good morning, everyone, and welcome to VEDECOM. Yeah, I will take some minutes just to share with you some challenges on the electrification of the e-mobility, and also to introduce this initiative, which is Mobena initiative. Do we do? I can. Yes, good. Okay. Let's start. Yeah. Now, as you know, as part of the e-mobility ecosystem, we are noticing that the complexity of smart charging is increasing. It's why we need multiple intervenees, multiple ecosystem exchange, and we need a cross-sectorial approach to address the upcoming challenges and the upcoming scales. We are noticing the moving from smart charging focused more on supervising charging station to smart charging integrated on smart buildings and smart charging integrated in smart grids. It is increasing significantly the complexity. It's why with our partners, we from 3 years now, we decided to build up this initiative, this Mobena initiative, to gather the ecosystem. Mobena is a collaborative project with the support from French public funding, and has the objective to accompany the introduction and the upscale of new technologies of smart charging, like plug and charge, and also this integration of smart charging. The mission of Mobena is to accompany, to coordinate the French ecosystem, to integrate the French ecosystem electric vehicle charging for harmonized and scale up of introduction of smart charging and plug and charge services at French level, but also for the European level. The idea is to share and to build and share together a technical roadmap to define an interoperability framework and also to allow testing and demonstration of technologies, and finally to disseminate disseminate the results and the positions for larger adoption. It's the idea of the project. The scope we are addressing in terms of feature, as I said, we address the plug and charge, which is a new technology to enhance the comfort of charging. We also address the unidirectional and bidirectional smart charging. In terms of protocols, as they are important for interoperability, we are considering the ISO 15182, ISO 118-20. We are also addressing OCPP 2.0.1 as to adopt this supervision protocol, which better integrate the ISO 158, and we are also considering OCPP 2.1 for the bidirectional charging. We have also some other protocols for the energy sector and also for back-end to back-end communication. In terms of use case, we are building our own business use cases, and we are considering the technical use cases from AEC 63110 and also some other standards for energy management and for energy management. We are considering charging at different locations, public, commercial, building, and also residential. And in terms of geography, even we are a French consortium of French interested partners, stakeholders to deploy solutions in France, but our vision is to ensure interoperability at the European level. The partners of the initiative are coming from different sectors. For the automotive industry, we have the two French OEMs, Stellantis and Renault Group. For the mobility service providers and CPOs, charging point operators, we have Total Energy, we have WhatsApp, we have Freshmile, we have Vinci Energies. We have also EVAC manufacturers. We have Hager, Legrand, and Schneider Electric. We have the two European platforms for roaming and PNC services, Object and Girev also with us. And we have some testing solution providers, important for interoperability. We have Vector and also Transpolis. And we have with us also the ETAS and Thales as techno providers. We have also the support from institutional partners. It's important to know what are the exchange in the other ecosystem. From the e-mobility, we have Aver France, we have PFA and SIAM. For the buildings and infrastructure, we have Gemelec and CGF. And for the energy sector, we have Think Smart Grid, UFE, for energy providers, and Polymede. Okay. Just to share with you some hot topics we are addressing today within the Mobena project. For standardization, we try to follow the ISO 158 Suri update, which is now on the way. We have also following the convergence between OCPP and IEC 63110, which is also a major point for the ecosystem, and other standards especially for the energy management, the IEC 63, 308, and 82, and also the introduction of V2G for the IEC 61851-1 edition 4. And we are also considering regulations as they will be very important for scale up the deployment of the smart charging or all the new technologies. We are considering the AFIR, the RED3, and the APPD regulations. We are part of the STF subgroup 1 especially to introduce the vehicle to grid, V2G, and we are also considering the work of ACER on the V2G, RFG, and DCC regulation. We have also not yet finished with plug and charge certificate deployment in terms of interoperability, and we are looking to make the pools interoperable and also to make the PKI, V2G PKI providers as more interoperable as possible. We are organized around 5 working groups. We have the plug and charge working group, the smart charging working group. We have also a group dedicated to cybersecurity, especially for EVACs, local CSMS and EVs. We have a working group specialized for testing and demonstration. And we have another group for the dissemination of what we developed as positions or as deliverable in the project. Finally, we achieved, we have, let's say, many achievements in terms of publications, in terms of participation to international events, in terms of also of organization of important demonstration for plug and charge and smart charging. It's all for me. Thank you, Hussein. Don't hesitate to take a word with me during the day.
Thank you, Murad. I think it's a call to join Mobena if you are already not a part of Mobena. So please feel free to speak with Murad, myself, or Amin for more details about Mobena. Okay, now we move to a very hot topic, which is plug and charge. This technology is indeed a central technology for user experience. And to talk about this, we are fortunate to have 2 experts. I call Jean-Marc Rive, the CTO of Girev, and Stephen Renaud, the director of plug and charge and solution at Object. They both leverage many years of experience, enabling them to pinpoint coming challenges and propose solutions that are not only smart but also scalable. So please, Jean-Marc, Stephen, join me here. Let us all welcome them.
Okay.
I think you need to be given the microphone.
Yes, maybe. Does it work? Yes. Thank you. Okay. A small technical check. Yes, it works. Okay, thank you. So I'm Jean-Marc Rive. I'm the CTO of Girev, and so we are on Girev's side. We are providing solution for plug and charge and for ISO 15118. And so we are working on that topic for 4 years now. And so today we will we will speak about the interoperability with my colleague Stefan.
Yeah, so also some words from me from Object. Object is working since a while on plug and charge. I think most of us know it because of roaming, but plug and charge is a thing. Maybe you saw it also on media, and you raised it correctly. Like we have a hot topic is plug and charge interoperability, and this is why we want to discuss several points to clean it up here together. So, Mark.
Okay, thank you. Up. Yes, first slide. Okay, thank you. So the plug and charge, in few words, the plug and charge is a feature for the EV driver, very convenient to start the charge on its car, and at the end the name is very powerful because plug and charge, you plug and it charge. This is very simple, and this is this very convenient feature that we are working about today and we are promoting. And behind this feature there is also something very convenient, as I say, but also something very secure, because at that time you have several players in the system, several subsystems, I would say, the car, the charging station, and behind that, the EV driver and the service providers and CPOs and so on. And all those actors will be authenticated at that step. And this very basic idea is about to secure the start of the charging station, the authentication of any subsystem player in playing a role in this feature. And so in the same time, we have a big improvement in terms of user experience, but also about the ecosystem securization. This feature is described in the ISO 15118, which is something behind the scene, I would say. And this is a key point. So I would like to highlight the fact that behind the plug and charge, there is ISO 15118, and ISO 15118 is something that brings a big improvement in terms of cybersecurity, and will also open new features, extra features, typically in the smart charging topic area. And smart charging is something very large for V2G and so on. So the ISO 15118 is behind the scene, and this is a key improvement, I would say, for the ecosystem. So the user experience is something that the user can see, and this is maybe the reason why the plug and charge will be deployed to improve that. But behind the scene, I want to insist and highlight the fact that we will make some very big improvement in terms of cybersecurity and smart charging. Cybersecurity, it means reducing the risk for the EV driver itself about paying only the charging station that he really makes. But this is also a securization for the grid infrastructure and for the electricity grid also. So a big improvement in the ecosystem. Maybe.
Okay. Yeah, so to understand plug and charge, we need to zoom out a little bit, because plug and charge is not an EVC thing, right? It's an end-to-end function. You as an end driver, you want to create a contract for your car, which you bought from an OEM, and you want to charge at the charging station from the CPO. So these are already like 3 actors in this ecosystem, and there's some more. With this slide, we want to show you the right side is authorization. This is known, target roaming by OCPI, by other protocols, to make sure that your contract can charge at a certain charging station. What Jean-Marc was just saying already was that with plug and charge, it can be done now automatically. It's not a replacement for roaming, it's not a replacement for authorization, it's just an addition for authentication. You have today an RFID card, not that secure, you have an app, you maybe have already a credit card, but now we add up like a new authentication scheme, which is the left side, where we can install this, let's say, digital secure RFID card into the vehicle, but the rest of the journey stays the same, because as soon as the charging station can make sure the ISO communication was legit, the certificates are legit, you can go to the authorization part. So really important to connect these two things. And we will also take now the topic. PKI is, let's say, an asset, what you need to have a secure communication, to exchange data in a secure way, signed data, encrypted data. So this is kind of the second layer, which you don't see on this picture. PKI are creating data which are shared between all of these actors. Can you click one more? Okay, perfect. And these are, for us, the hot topics which we see in the market. We have the discussion about multi-contract. What does it mean? You as a user have multiple contracts for your car. We know some OEMs have some implementation out there that they install the Porsche contract or the Mercedes contract and so on. This is already available, but the customer doesn't have the big choice here. But maybe you also saw it, we drove with the BMW over here. There's already multi-contract available. So we have also later a speech about this. But it's important to understand and to see for the scalability, multi-contract needs to be established. The second thing is -20, -2. -2 is now available, or let's say the hockey stick is in the rollout, but -20 came out 2 years ago, 1 year? 2 years ago. So, yeah, well, it wanted to come out earlier, but let's say 2 years publicly. And Dash 2 took 10 years almost to come to the place where we are today in the rollout. So we need now also Dash 20 to give some time to get in the rollout, but these two norms are not compatible. How do we tackle this? It's more an EV topic, not less in the backends, but still, it's a complicated topic. We have the synchronization of pools, or the pool operation, and the joint protocol for plug and charge, because as we had it in roaming, I think you might know better than me, because I joined later, but in roaming there were years of discussion about the right protocol, the different protocols, and it's still kind of a challenge, and maybe we can make it better in plug and charge to have a unified protocol for the whole world, or at least for Europe. And then the last topic is multi-PKI, which is getting mixed up sometimes, right? So it's possible to have multiple V2G PKIs, multiple MO PKIs and MSP PKIs. That's totally okay, and this is a key for the neutral and rollout for everywhere in the world. We will start now with the multi-PKI, or what does it mean to be interoperable with PKIs, and then with ecosystems.
Okay, so we see that we have a question about interoperability, and more than a question, we have answers to that topic. So this is a great news and very positive one. So about interoperability, so the interoperability is a complex word, and behind this word, this is the idea of that two systems are interoperable if they are able to manage to perform a single one process, and so to collaborate, to exchange information, to synchronize, and so on. So this is a question. This is an ability of systems for collaboration, and for sure we know that in the EV ecosystem we have several car makers, we have several charger makers, we have several CPOs, EMSP, and so on. So very fragmented situation, fragmented market. So it means that the question of interoperability is key, because we know that, and there is a kind of motto, this one written in this slide, that the basic principle is that an EV driver could be able to recharge its car, whatever the brand of its car, on any charging station, whatever the charging station, the brand of the charging station, the CPO managing the charging station, whatever also his choice of EMSP and service provider, and so on. So this is this complexity of having and being compliant with several players, several roles, but several players in each role that we name interoperability. This is this topic. And the interoperability is key for having a fair and open market, because the symmetric situation would be monopoly. In a monopoly, there is no question about interoperability, but we have some other question, and I'm sure that we share all together the position that monopoly is not a very good solution. So this is the reason why interoperability is a key subject. And so today my first message, and I'm sure that Stefan will share it, is that this is not a challenge anymore. This is a reality, and now we have solution to tackle this target. And this target is a fair and open market. So this is not a subject of technology and something for IT people. No. This is we are building the open and fair market of today and for tomorrow. So this is a key point. We can split this question in two parts, because I know that we are here with tech guys, tech girls. So okay, go back to the reality of tech things. And so we can split this question of interoperability in two parts. I'm talking about ISO 15118 and plug and charge. Two main parts. One is about PKI, one is about data exchange. So data exchange, we know that for years now, because we managed that for a long time. For PKI, this is something a bit new with ISO 15118 and plug and charge. So, and maybe we could spend some minutes about that. So, in terms of PKI, behind the PKI, the idea is the trust. So, when someone an actor is connecting to you, you want to check who it is. if I can trust him, and so on. So this is the PKI is an IT tool for managing trust. So, but the question behind is trust and not IT at the end. So, the second part is about data exchange, and more classical, but this is a topic for today also. So if we are looking on each, I would say, pair of actors, we can see that we have the first thing is when you plug the car on the charging station. So there is two subsystems, the car, the charging station, that have to establish a connection. So for tech guys, this is a TLS connection. But at the end, there is a question of trust. Do I accept this vehicle? Do I accept this charging station? And so there is a question of trust. And so at the end, this is quite easy because in ISO 158-2, there is only one way checking the trust. And so at the end, this is very easy because we only need to have the route EA or the charging station in the car, and that's it. The second point is between CPU and EMP. And yes, there is a question of trust. We saw that, and of data exchange. Data exchange is not so complex. About trust, it means that when a CPU and an EMSP want to work together, they have to establish trust. It means that the CPU must enter the EMSP in its what I can call trust store or trust list of actors. Ooh. And so here also very easy, very simple, and already fully described. So there is no big complexity. We have the same question for backends. I would say for IT backends between EMP and EMP, OEM, and CPU. At that level, the main topic is about exchanging data. So as Stefan said, we split two questions. The first one is about creating and managing the authentication token, the famous contract certificate. And so behind the scene, we need to establish connection between OEM, CPU, and EMSP to manage that. And there is a commonly accepted solution, architectural solution, which is named pools. Pools are shared storage, data storage area, and so and they are provided as a service. And so we in the current situation, we have several players for that pools. But the solution already exists, is active, fully operational. So this is only something to deploy, but no key question. Yes, the last point is about the relationship with the EV driver. A key point here is that, as Stefan said, we have this topic of multi-contract. The subject behind that is the choice of the EV driver, the ability for the EV driver to be able to choose its EMSP, whatever the brand of the car, whatever the charging station. So we must be ensured that the EV driver can choose that. So he can choose the EMSP he wants, even if he chooses to have several EMSP, because maybe he wants to use this kind of contract for that location, this other for another location. So this question of the freedom, I would say, for the EV driver to choose the MSP is key. And we have to pay attention, because we are talking about systems, that whatever the way we implement the solution, we have to be sure that the selection of the contract certificate is always made with the consent, explicit consent of the EV driver. This is a key point, and we have to pay attention to that. And so we also have solution to manage that. So this is not a big thing, but we have to pay attention to that. So rapidly, we have in this slide what is required to ensure interoperability. So very rapidly, we say that on car, the main topic is to add in the car all the route EA, so the route authorization authority in each car. And based on that, the car will be interoperable with all the EVAC, or the charging station, which is key. So the second point is the fact that we will have several routes here, several authority, and so we worked on the STF level about that, and so the solution is now fully accepted that we will manage what we call a certificate trust list, so a list of trusted entity, and based on that, everybody will be able to say, okay, this actor belongs to the trust list, so I can establish a trusted relation with it. I try to accelerate because time is running. And so about that, it means that behind the scene also we need to establish a clear and fair governance and some commonalities, because to ensure interoperability, we need common rules. And the interoperability is always based on common rules. So common rules in terms of governance, common rules in terms of technology. So with the STF is a working group managed by the European Commission, something like that, to simplify. We establish a big list of best practices, of market rules, but also on some tech requirement, but typically we work on the governance, and we also say that yes, we are in favor of a market based with several actors, not a monopoly. Yes, we want to govern this multiplicity of actors, and so on. And the other part about technical is this is the scope of the Mobena initiative. On Mobena, we worked more. We are working also on governance, but the main focus is about technical things, typically about defining architectural pattern, but also working on protocol, describing use cases, and standardization also, and working on the rollout of the technology. A last point about this this regulation. So the beautiful picture you see on the right part of this slide has been produced in the context of the STF subgroup. But the idea is that this, I would say, architecture pattern or governance pattern, we think that it will be likely deployed for other region in the world, typically in the US. This is a template on which you can base your thinking, because it will. We think that it will become universal. So this is our push for today. But so you see in the upper level the governance architecture about who decide who is in the trustees and so on, and also some technical parts, typically the famous CTL. You see all in the middle all the PKIs. So because we decided that an open and fair market must have several players. So you see several players in the gray zone, and you see at the bottom external player, typically OEM, CPO, EMSP. And in between these blue players, you have the orange players, which are the interface between this, I would say, governed area, PKIs and so on, and the external. So, and those orange players are service provider to CPO, MSP, and so on, to ensure this the full interoperability between PKIs in terms of trust, but it's also in terms of data exchange. Thank you. Yeah.
Thank you. Okay, thanks so much for the PKI world, and I think it gets clear. PKIs coexist next to each other. They don't need to have a link between each other. This is even technically very complicated. They need to coexist, and the market is consuming them. We are doing this every day in our laptops, phones, to have trust. Now coming to let's make it pragmatic. If you are a CPO, MSP, and OEM, and you want to do plug and charge, what do you need to take care of? So if you're a CPO, of course, you need to first check what kind of hardware do I have in the market. Is the hardware ready? Do I need to replace a controller? Do I need to just replace the software? So this is currently what's hindering some CPOs in a quick rollout, because they have diverse hardware. And so for every hardware, they need to talk to the vendors and need to get a roadmap when to roll it out. And it's also not nice if you have some chargers capable and some chargers not. So this is because I get often the question, like, why do we have not like millions of chargers yet? This is the thing. It's about interoperability between CPOs, charging stations, and ISO. If you're an MSP, yeah, so you're just a backend, right? You can do what you want. It's more HMI related. You want to offer plug and charge to a customer, open up a HMI for the customer where you can enter this PCID of a car, and then you can generate a contract. There's no connection needed to the OEM. There's no connection needed to the CPO. It's done with these pools and services. So just choose the platform you want to use, and then you can generate contracts for these cars. The only thing, and now we're coming back to PKIs, you can choose if you want to run an own mobility operator PKI. It's kind of a question of, I would say, money and trust. Do you trust someone else in operating your PKI, or do you run it yourself? But then you have to carry the cost. Running a PKI is quite expensive. The OEM has, of course, some more parts to do because they're usually bigger. They have the car, the vehicles, they have backends, so they need to go through a long process of automotive development, which takes usually 2 to 4 years to have a car ready from, hey, let's do something like 1511.8, plug and charge, and then having it on the field. It's good to see now finally the cars on the street, but it was years of development, mostly by the OEM. It's not about the ecosystem. Oops, no, can we go back one? Yeah. I raised the topic before, the common protocol, because we need to have a protocol, and every actor needs to understand how to use certificates, how to exchange this data. I think 1 year ago or 2 years ago we started this working task force with Charin together to bundle with all the actors in the market what could be the right protocol to exchange the data, where the CPO, MSP, and OEM directly know this is how I exchange data, and if I want to switch systems, I can easily switch without the burden of changing protocols. And OPNC was the result published beginning this year, right? So Charin published it. I also added the link here to GitHub. So it's governed by Charin. If you want to have changes or if you have comments, join this working group of Charin. You can go on GitHub. You can even make pull requests if you want to have a change. They need to be discussed, of course. We try to make it as interoperable as possible, backward compatible, that everyone who's doing today plug and charge doesn't have to have a pain, that they can continue with the development. They don't need to start from scratch, which is key. Otherwise, we break again without reasons. Okay. One important thing, we added the OPNC facts on the side, but multi-PKI is one thing. So the protocol is able to use different V2G PKIs, different MO PKIs, and so on. But also, there is a link possible between one system and the other. Today, it's described as broadcast. So it's possible, if you are connected to one ecosystem as an MSP, to generate a contract for a different ecosystem. Of course, what's missing is the governance. How do these ecosystems work together on a governance level? This is currently in a clarification in these working groups. But technically, we have a solution available, which can, of course, be improved, but there is something available. Yeah, so what does the CPO need to do? The CPO needs to connect to the system to issue certificates for all the charging stations. This is done automatically. If you go over to the testival, most of the chargers are connected to a CPMS, which is connected to our ecosystem. And so we do this automatically already on the testival. It's an end-to-end plug and charge over there. The OEMs do this as well. Some who are more in the early stage of the development do it maybe manually, but over there it's already happening that these chargers are getting live EVC leaf certificates. The same for the routes. Jean-Marc said it. MO routes are also available. They need to be installed in the chargers. This is done via ecosystem, so there's just one button, one click, or one process of the CPO, and all chargers in the field are getting the same trust list for this available market. And the last point is a CPO should offer a contract installation over the charge point. If there's a kind of a car which is not online connected via their backend system, they want to install over the charging stations. But more OEMs are tending to install over the telematic way, the contracts. I mentioned the MSP has a customer. They need to offer an HMI to generate a contract, and it's really important. In Dash 2, it's possible to create multiple contracts for one EV. So there's a false understanding that just one contract is available. No, if the car is reserving enough memory or is preparing telematic-wise to have multiple contracts and showing it to the customer can create a contract, and later you will see it. We can generate live as a contract here on stage, and you will see it directly in this productive car. So there is no need for like discriminating or whatever. The systems are already ready to do so. On the right side, I just made a list of one car which has 4 contracts, for example, for the same PCID in the ISO language. So an OEM has a little bit more to do. What I said, they should download the list of routes, later from the CTL, from the European Commission, but also later from the SAE in the US. Today it's more route pools, which are locally driven by companies like us or JF. The OEM needs to provide the provisioning certificate to a pool operator, to a provisioning certificate pool. Why? Because we need the vehicle certificate to encrypt something later for the contract. Later, on the bottom right, you see the mobility operator is a customer facing. The customer is signing up for a contract. They use a CPS or a contract certificate pool, and then the contract can be installed either over the charging station, the upper way, or the middle way over an OEM telematic way. So you see, connecting to a system like a plug-and-charge system is easy. Like there are just 3 or 4 API calls, and for everyone who is a little bit in development, like, okay, it's not so complicated. There are norms in the cars and charging stations which are more complicated in developing it. Connecting to a system is not rocket science. This looks crazy, right? It's kind of the extensive picture of Jean-Marc or from the STF. But it should show like kind of different cars in the market and also different charging stations. And the colors should show, hey, I'm connected to a different ecosystem, I'm using a different PKI. But what we have already running today is the PKI level. So on the, maybe I'll go here. On the PKI level, there are different PKIs available, and they need to be governed by guidelines and regulations. So this is in place in the US SAE and in Europe for the STF. Asia, we need to see. I think it's a little bit more complicated with all the different countries there. But we will make it. At one point, we will make it and maybe copy some of the ideas. The system, ecosystem, this is what I just explained. We need to have links between the systems that these pools are, like have a connection. Not talking about synchronization because of like data protection. It's not allowed to copy too many data, but on demand, data can be exchanged. And so if an MSP is connected to this system, they can create over this link a contract for a different car. This needs to be able and it needs to be possible for the freedom of the customer to choose any operator they want to have, but also the freedom of these mobility actors to choose systems. Because you want to have something running today and don't want to think like, okay, should I wait or should I connect to this or this? This shouldn't be a question for you. We know interoperability is a quite tough topic and it's multidimensional, but I hope we were able to explain you a little bit the side effects of PKIs, but also ecosystems and synchronization of pools. I think now it's the time for discussions. How much time do we have? Yeah, okay. Then, any questions to Jean-Marc or me? For the fun part of interoperability of PKIs and ecosystems. Otherwise, we can save some time.
Maybe I have a question.
Don't care.
So, you were talking in an optimistic way. Right? You are saying that we are almost there. What are the remaining challenges?
Yes, first part. Challenges is not the right word because we don't face challenges. We are in a phase of rollout solutions. So there is no big deals. As we described together, we don't face big difficulties. We have things to do, and we know what we have to do. I mean, as a PKI ecosystem service provider, but also we know what has to be done by OEM, EMSP, and so on. So, and things are not so complex. The last slide show something like that could seem as complex, but at the end we know very clearly what has to be done. So no big challenge. The real challenge is to start rolling out the infrastructure, the cars, the service for EMSP, and that's it at the end, because we know everything about how to deploy that, and this is my key message. And there is likely some maybe challenge in Asia, because as we said, the ecosystem is fragmented and there is no common organization, cross-country organization to manage that. But in Europe and the US, things are very clear, and so there is a job to be that must be done, but no big challenge. So my answer to your question is that we don't have any challenge.
Charming in here. So of course, PKI was a topic for the last year. So we have a problem, but people needed to understand PKIs. And the understanding is usually, since I'm working for Haptic, I'm explaining plug and charge. This is, I think, 50% of my time of explaining and not doing, which is important, right? Because it's complex. We have multiple dimensions, so many stakeholders. Everyone needs to do something, and then there are these crazy certificates. It's more understanding. We have now more controllers in the market, which you can take for your EVSE or for your car. You don't need to start from scratch. And 5-6 years ago, everyone started from scratch to build something and to understand independently, because of course company wants to do it on their own. But now, also with these kind of events, people are sharing information, and it's getting better. PKI is governed, and the ecosystems are already running. So Jean-Marc was totally right. Don't wait, just do it. Start to roll out. Maybe don't aim for 100% perfectionism. Just do something to learn on the suspect and get help if you need support. It's no problem anymore.
Another question? Yes.
Yes, thank you. It's been kind of prolongating your question, because we are in the time of rolling out the solutions. And as you mentioned, there is a question of hardware readiness. It can be in the charging station or even in the cars. And what we see is that the protocols and standards are always improving, but it means also changing. And so is there a definition of hardware readiness? How do you deal with that? Because as charging point operator, I guess you do not want to change your hardware at every release of the protocol. So how is it tackled, and what is your visibility on that?
So this is, of course, every hardware manufacturer needs to see how future-proven do we want to be. And the problem with some cars, I think almost no car which is doing Dash 2 today is not with software updatable on Dash 20. This is clear, because if you add €1 to a car for having like more memory for the future, you add millions of euro for the rollout, for some safety. So this is why usually, especially controllers in the cars, have the the needed maximum, or needed minimum to be capable. So here, sometimes the interoperability is getting a problem, because they need to create new controllers which can do it, and then the legacy cars can't do it. I see the possibility in the charging stations, because they are not under the automotive development like strict cycle, so they can be more flexible in doing software updates. And if I would be like a hardware manufacturer, software manufacturer for EVCs, here saving some memory, which is mostly the key, is easier than in the car. And if you reserve some memory, you're ready, and have an intelligent software update mechanism, not a haptical one running to every charging station. It sounds so easy, but it's really complex, because it's a matter of how much money do I want to spend today to be ready for the future. So everywhere's a problem, right? But I think lessons learned, especially in the Dash 2, in the first Dash 2 implementations, the lessons were learned for Dash 20 as well.
A last word about this question about the need of certification, because we said that the ecosystem is complex due to the big numbers of subsystem, car, charging station, pools, and so on, and also very fragmented in terms of actors. So it could appear like a big mess at the end. But we need not only protocols and technical definition, but we need also the ability of testing things, and also about certification. And I think that this is something on which we an axis of development, because at a time we say any car must be compliant with any charging station. So how to check that, how to prove that, or how to design it, and so the question of verification of testing will be key, is key. And if we say that any car maker must test his new car with any kind of charging station in the world, maybe it will be a big mess, a bigger mess. So at the end, there is a need for certification to be sure that if I manage this step of testing, I'm sure that my car will be compliant with any charging station, and vice versa for sure. Car was only an example. So I think that one of the element for your question is about certification, test and certification, and this is exactly the topic of the festival today. So we are in the right place for that. But I think that this is not only a need for a starting point in time. No, we will have a need for this kind of things.
Yeah, last question. Yeah, please.
Thank you for the presentation. I have a question regarding the rollout of Plug and Charge. Do you have any insights on AC charger Plug and Charge rollouts and the ISO 15118-20 rollout also? Because now we have the DES2, but yeah.
Good point. So also important, AC plug and charge is the same as DC plug and charge. Of course, in the communication in general, there's some slight differences. But why don't we see so many ACs today? Because the DC networks, which have some money, they spend some investment into plug and charge. And also the OEMs push them to do it. What we see now, at least at Hubject, we get a lot of requests from depots and fleets or parking lots. They want to commission a lot of AC chargers in the field. And I think we just certified from Hubject in our lab like 3-4 EVC manufacturers. I think IoTeca is also now here. They did AC already since a while. EB is here, like the vendor controller can do plug and charge as well. So there are already a lot of stations out there, but who is hindering today? It's more the CPOs who are not aware that plug and charge is also working with these stations. So here again, a shout out to the CPOs. If you're AC, or if you have a nice parking lot with 5,000 parking lots for your company, do plug and charge. You can do great company charging spots. That's the one. And for Dash 20, the driver for me is more currently like in public road is the commercial vehicles because MCS is requiring Dash 20. So if you go over there, you will see some Dash 20 testing over there. Rolling out on the street is then would take a little bit time or more on the MCS side. But the driver for Dash 20 is not plug and charge because it changes just the security. Of course, it's important. But bidirectional charging, smart charging, these are the use cases why most companies are doing Dash 20 now. And so this is now, people have the idea to want to do it, like an OEM. But now, do I do it in private or in public, right? Because private, it's easier. And usually, everyone starts with bidirectional charging in private and not in public. So now the DC networks, which have invested in Dash 2, they are not interested fully in Dash 20 because bidirectional charging and DC networks, maybe not the best use case for now. But so here I see the Dash 20 coming more from the commercial vehicle side or more some smaller application at home for Dash 20. But it's coming at least. And you see Dash 20 already since a while at the Charging Festivals working. Also with plug and charge, we did already on our ICNC 2 months ago, like an end-to-end plug and charge with right PKI and the right controllers.
Yes, maybe we can say that about DC charger. So the question, I think that the question of how to introduce the cost of the initial invest in the technology is much more easier in big DC charger, which are quite expensive. So we can introduce a new cost for the invest of of ISO 15088 and plug and charge. And it's not so easy in a very small AC charger, which has a price, a very low price compared to DC. But I think that as Stefan said, that the AC charger is very key for fleet. And fleet, the plug and charge itself, seen on the EV driver side, is not very key, I guess, for fleet management. But the security behind that, and also the ability of managing smart charging is maybe much more important on fleet side. So plug and charge is relevant also for fleet, but I think that on fleet side, the smart charging and the security is also something that very key, and including the AC charging.
Okay, thank you. Of course, you can. Of course, if you have any questions, you can discuss with Jean-Marc and Stephen during network session, during the break, or even send them an email to talk more about this. So two things that I understood from, or two key things that we can take from their presentation is about the readiness of PNC, and the second is about the importance of test and certification, which is actually the focus of our next presentation, which is about ensuring automated conformance and interoperability test for ISO 15118. Fennel Eber, Senior Product Manager at Vector. Please, the floor is yours.
So, bonjour and hello also from my side. First of all, I would like to thank VEDECOM for hosting the conference and also hosting the Charn Festival. I would like to talk with you about conformance and interoperability, which is an important topic. So I hope you all arrived safely with your electric vehicle and found a charging station. I see two participants who found a very good parking spot here and charging stations, and I hope the rest of you also. But one question, I think you are very experienced electrical vehicle driver. So who of you had already some issues with charging? Can you please raise your arms? Yeah, not all, but let's say half of it, yeah. So the question is to solve this, yeah, and to make charging a nice customer experience, what has to be done? And on our perspective, we have to test it, yeah. And testing starts at multiple stages of your development. So what you see here, if your charging station and your electric vehicle, yeah, you can use conformance and interoperability tests like the Canoe Test Package EV or the Canoe Test Package EVSE. And these test cases you can execute with a test system like the VCTS. So we have this test system on the other street side at the Charn Festival and test charging stations and the vehicles with one system. But some of you maybe think, yeah, but if the vehicle is already manufactured, can we maybe test earlier in the development process? Yeah. So you can use the same test cases also on controller level. So that means you have the same software for testing, but you can execute it against your electric vehicle charging station side, but also on controller level. And we had already in the previous presentation the topic, first you have to check for plug and charge, for example, that your hardware is ready for plug and charge. But in the end, it's just a software topic. So you can test plug and charge on software level. So that's possible. And you can also use the same test cases. So I think this is maybe to make it easy, yeah, for your development process, use the same test cases, all integration levels. And I guess you will find every time a new issue in your software, in your ECU or then in your whole system, because the system gets more and more complex if you have it bigger, but divide it and conquer. That's my advice for best practice to go into the market. So I want to give you the overview again about our best practice. So we have the same test cases on all integration levels with different possibilities to connect your software or your hardware. And I would like to start with the test cases. So the good point is you don't have to implement your own test cases. Test cases are already defined by the ISO 50118, -4 and -5, and we implemented with our Canoe test package EV and EVSE. And we have already the first ISO 50118-20 test cases. Yeah. We already heard it 2 years ago. ISO 15118-20 was published. We already have some test cases, and we also deliver the source code of our test cases. So that makes it for you possible to write your own customer-specific interoperability test cases. And we have also a nice feature for storing the tail as master secret in our log files. When it comes to plug and charge, it makes it easy for you to send a log file to a colleague or to some other people that they can analyze maybe the issue during a plug and charge session. And of course, we don't only support CCS, we also support CHAdeMO and GPT when it comes to the Asian market. So, as I said in my previous slides, we can execute a test case on multiple integration levels, but I will start now from bottom to top, and bottom means software in the loop. So with software in the loop, you can create your own virtualized ECU. And this can be done with VAR Virtual Target when you are OEM. So then what is the question, how can you move then from software in the loop to hardware in the loop? And you see here the difference. The difference in your stack is only the MCAL and the OS. So for the software loop, you need an MCAL, which is possible to execute it in a software in the loop environment. And for the ECU, it's needed to be an MCAL and an OS, which is supporting your controller. We have also a solution for our charging station manufacturers. It's called the SILKit. And SILKit can be used also in the Linux environment. So Linux is an SILKit is an open source ecosystem from Vector that enables you to connect your virtualized ECU as a charging station manufacturer to a test system. So we can simulate an EV, CSMS, also power supply unit. This is all possible. It's depending on you how complex you want to have your test setup. The next step is to use a VT system. So this is already possible to test also like plug and charge test cases just on ECU level. And the nice feature here is that you can add additional cards if you want to test some additional communications like CAN, FlexRay, LIN, or whatever you have in your ECU. And what we have here, the Charn test level, is our vector charging test system, the VCTS. And with this system, you can execute the test cases on a system level. So you can bring your electric vehicle or your charging station, plug it in, execute it, and then check if every test case is passed. To give you a summary, so our big advantage is you can execute the test cases over all integration levels. Then we have a nice feature to TLS decrypt the traces. You can access all internal bus communications, so our tool Canoe supports all the communication protocols inside your vehicle, but also if you have, for example, a charging station, we also support OCPP, and we also support CAN or Ethernet if you have a communication between your controller and your power supply. And we deliver the source code of our test cases. That makes it possible for you to write your own test cases, add additional test cases, write custom-specific test cases. So I think that's a good solution. Again, I want to show you the V model here to see what we support here. And when we zoom out a little bit more, what is Vector doing? So Vector is over a decade in the field of e-mobility. So we have software for the electric vehicles. We have software and hardware for the charging station. And in the middle, you see also our solutions for testing, analyzing, and simulating smart charging communication. So thank you very much. If you have any questions, you're welcome. Over there.
So thank you for the presentation. In your very first slide, you were showing a bus charging with a pantograph. So I have two questions. Does it mean that your testing system can also test for the 1511.8-8? And can it also work with automatic charging system, either by induction or by pantograph?
Yeah. So you mean upcharge, for example?
Upcharge, or the upcharge is Volvo trademark, so that's the reason why I do not use it. But I was just mentioning the ISO 1511.8-8 or the 61851-23, something like that.
Yeah. So we have a solution for Wi-Fi communication. So we can simulate a vehicle or a charging station for Wi-Fi, or we have also a solution to only listen to the Wi-Fi communication. So this is possible. Yeah. Okay. More questions?
Hi. So you mentioned all the test cases that you can run with the test system, but I'm wondering if there is a regulation that make the vehicles or charging station to pass all these test cases. That so this will enforce the manufacturers to produce vehicles and charging stations that are already interoperable, or for now it's free for everyone to test whatever they want and pass whatever they think they should pass.
Yeah. It's a good question, yeah. I think the first regulation is maybe the customer, yeah. If the customer is not happy with the charging station or with the electric vehicle, he will not maybe buy it, yeah. But there's also like institutional regulations. I know there are ongoing discussions in the EU and also in California, yeah, to make it mandatory, yeah, to execute and pass the conformance tests. More questions to this topic?
Okay, thank you a lot, Fidel.
Yeah, thank you.
I want to remind you that we will do several demos within VEDECOM conference today, and we have, of course, Sharon Testifiel in the coming days, where there will be a lot of testing, including Funnel and Vector. Now, let's move to another very important topic, which is cybersecurity. So as EV ecosystem is expanding, cybersecurity has become even more important. And to address this topic within the EV ecosystem, we have Jill Shen, the business developer at Thales, which comes with more than 15 years of experience and will address the risk and priorities within the EV charging infrastructure. Please, Jill.
Hello, good morning. So I am Gilles Chenet. I am doing business development in Thales. So I will do a quick overview of what Thales is doing, and then I will explain why cybersecurity is a must in this ecosystem. So Thales, it's 81,000 employees in the world. We are present in the 68 countries. We are investing 4 billion euros with 1.1 billion euros in R&D. We have 18.4 billion of revenues. And we are organized in 3 marketing segments. So one is the airspace, one is defense and security, and one is dedicated to digital identity and security. And this is in the last one at the bottom where the smart mobility vertical is present. In this vertical, we develop connectivity and cybersecurity solution for our customer, helping them to connect and cyber secure their product. We have a lot of customers, cities, enterprise, governments, institutions. So today we will talk about cybersecurity. Hacking in EV charging is a reality today. We heard, we saw. Some publication disclosed by hackers or researchers on the risk to have cyber attacks on the ecosystem, either on the charging station itself, either on the back-end systems. So we will have some example at the bottom of the slide. So more and more devices are connected today. The attack surface is increasing, and then cyber attacks are growing also. In 2021, the increase of cyber attacks was around 300% on critical infrastructure. So this is a fact. And 4.7 million euros was the average cost on cybersecurity attacks on the energy sectors. So it's very important. One report from upstream mentioned that EV charging attacks represent 4% of the smart mobility incident in total. So attacks can lead to data breaches, fraud, denial of service, and production interruption. There is different types of attacks. Unauthorized access on the charging station, on the charging station management system, on the cars. There is malware and ransomware also attacks by taking control of the charging station, for example, by injecting some malware within the charging station. We have also network attacks by using botnets in order to generate denial of service on the charging station and on the backend systems. We have also firmware and software vulnerabilities. So we need to pay attention to update regularly the software of the charging station, some operating system layers. And finally, physical attacks. So the hackers is in front of the charging station in order to take control on the software. So in terms of example, we saw hackers, Ukrainian supplier of charging station hacking the charging station on the field in order to disrupt the service of EV charging. We saw some hackers injecting some inappropriate contents on the screen of the charging station also. More recently, you heard about the QR code sticking on the charging station as a phishing attack in order to take banking card information of the user and perform some payment. So lot of incident, I will say, in regards of the EV charging ecosystem and attacks. So for the time being, it's not so strong, but because more and more EVs will be deployed and charging station will be deployed, the incrementation of attacks will come. So there is different challenges for cybersecurity. First is political. States and governments must keep sovereignty on their critical infrastructure. So the energy network is one of the critical infrastructure. But also to succeed in their engagement, ambition to move to zero emission with EV deployment. They need protection of the infrastructure and the trust of the citizen in this infrastructure. The risk can be economical also for all the stakeholders of the ecosystem, the charging operators, the user themselves, and also the aggregator. I heard recently that researchers demonstrate that it was possible to modify the charging profile in terms of user preference in order to change the consumption of the energy on the network. So that can have two impacts. One is to load the network, the energy network. And the second is also to have an impact for the aggregator according to their engagement with the energy market. Technically speaking, as said by my previous colleagues, there is a lot of actors, entities in this ecosystem, and it's very complex to deploy the security in these old entities in order to make the trust between each of them. Also, the charging stations are connected to critical and vital infrastructure, so we need to pay attention of the security, the cyber security that will be implemented in these devices. We have also to pay attention about the lifespan of the cars and also the charging station. They are on the field for several years, so it's very important to plan, to be able to renew, to patch the software, and to renew the certificates. So the standards, the ISO 15118 and also CPP, take into account of this capability to upgrade the charging station on the field. Finally, the last challenge is about regulation implementation. So yes, thanks to the ISO 15118, we have the rules in order to install the trust between all the entities. But there is also the Cyber Resilience Act that is mentioning the duty of all the stakeholders in the chain, the charging station manufacturer, but also the distributor, the operator that will manage the charging station on the field. And if there is some issue by following these rules, some penalties will be applied to the stakeholders. So it's very important to take attention of that. So how to protect the EV charging ecosystem? So first, we have to apply the security by design approach, meaning that starting with a risk assessment in order to identify the potential risk, the potential attacks and vulnerabilities of the charging station, but not only the charging station, there is also the CSMS, the charging station management system. We have to consider the full system and then having a focus on the subsystem. Charging station is a subsystem. The charging station management system is another subsystem. So on top of this risk assessment, we will be able to design a secure architecture that will integrate the security basics. We have also to take attention about the privacy protection in order to protect the user of the data that will be in the charging station or the charging station management system. And also to be sure that only the dedicated data will be managed and not the unnecessary one. We have also to pay attention of the access control. It's very important to implement a strong authentication, mutual authentication between the different assets in order to avoid hackers to take the control of the system and inject malware or modify the software, modify the settings of the charging station. We have to pay attention about secure communication. The charging station is connected to different networks, cellular networks, to the CSMS, or via Bluetooth, via Wi-Fi, connected to a smartphone, for example. So it's very important to protect the communication by using secure protocol, so TLS protocol, HTTPS protocol, between the charging station and the backend systems. Finally, as I already said, pay attention to regularly update your software, deploy patches according to the evolution of the operating systems. And finally, you can also implement intrusion detection software in order to monitor the activity of your charging station, in order to detect abnormal behavior of your charging station, and then take appropriate actions thanks to a system that will operate on the back-end side. So ISO 15108 relies on PKI framework. We already discussed about that, to provide trust and secure the full ecosystem. So it's a good thing. So as Thales, what we are providing in order to help to secure the ecosystem. So first, we are delivering consulting for cybersecurity, helping, supporting on the different standards and regulations. We are performing with our partners and customers the cyber risk analysis. We are also writing specific recommendations in order to design a secure architecture. And we are performing pen testing in order to validate that the recommendation and best practice are well implemented in the product. In terms of assets, we are providing secure hardware and software. So we have a secure element, so it's a secure chip, tamper-resistant chip that will be soldered in the device in order to provide secure storage of keys and certificates, managing algorithm cryptographic operation also for verification of the signature. And we are able also to bring a specific piece of software in order to make a robust access control. We are also providing threat detect and response solution. So it's a software probe that is installed in the charging station in order to monitor the activity and detect the attacks, connected to a backend with artificial intelligence and machine learning in order to analyze the data and generate alerts for operators to treat some action, to, for example, stop the charging station. We are also providing a solution in order to help to secure the identities that will be deployed in the cars, in the charging station. We are able to generate certificates also, and to download these certificates in factory in order to bootstrap the charging station with the security identities. and also being able to do such things during the life of the charging station as soon as deployed on the field. So these certificates have an expiry date, so it's possible, thanks to this solution, to renew or to revoke the certificates. So I'm done. So if you have any question, don't hesitate. Thank you.
Questions? Okay, I have
Okay.
one question.
Okay.
So, how much can we reuse from the tools of cybersecurity coming from Internet of Things IoT in the case of electric vehicle charging infrastructure?
Yes, indeed. Actually, IoT devices are connected to the network, so it's very important to inject at the manufacturing of the IoT device certificates, public keys, in order to provide a secure digital identity of the device. Having this security identity, the device will be then able to be authenticated by the backend and create a trust between the device and its backend. So the tools that are used for any IoT device can be reused for the charging station. This charging station is one of the IoT devices that we know.
Okay. Any other questions?
Someone.
Please.
Yeah, my question will be very, very specific. Because you have mentioned the global world in which we have electric vehicle and charging points, but I wanted to refer to the public transportation market, and where today most of the equipment which are purchased by public entities. So they have the capability to ask for their suppliers to take in charge the cybersecurity requirements. And within the regulation today, which type of tools do they have in order to oblige their suppliers to implement this type of cybersecurity obligation that you have mentioned? That's my first question. And my second question, to which extent you, as consulting company, or how could you help these public entities in order to implement this type of obligation? Because you have mentioned how you could help the industry and the suppliers, but my question was a bit more specific. How could you support and help the public entities which will have to purchase this type of equipment, and more specifically for public transportation?
Okay, there is several questions in one, I will say. So first, it's important to comply with the regulation. So regulation is bringing rules and duties. So companies that are creating the device have to follow such. Either they have their own cyber security experts and capability to design and implement the best practice, I would say, to secure the device, and it's good. Otherwise, they have to rely on companies that are expert on cybersecurity in order to help, to support. It's better to think about that, to think about cybersecurity at the design of the device, of the product, in order to integrate cybersecurity requirements and methods in the fundamental layers of the product. Then, so this is for the manufacturer itself, and then for the users, they need to ask guarantee of the manufacturer that he did the things in a good shape. Otherwise, it will be the responsibility of the manufacturer and the one that is operating the device, selling the device, to manage the compensation. We are able to perform some analysis post-production, post-manufacturing of the device. We perform penetration tests, for example, in order to assess finally what could be the resilience of the device in front of cybersecurity attacks. So this is something that we can do afterwards for a customer willing to assess the security of a device that has been already deployed on the field. Did I answer to your question? Okay.
Okay, last question. Yeah, I mean, please.
We are talking a lot about second life equipment and recycling. Are there any things or preparation for this topic in the safety security area?
Yes, what I am saying is about the change of ownership of a device. So as soon as the device is remaining in the same form factor than its first life. So in this case, thanks to PKI, once again, it's possible to update the certificates that will be generated or trusted by another certificate authority. So if the owner, so one example, it's not exactly about second life, it's just, for example, the change of the CPO that will operate a park of charging station today. He has a contract for 3 years, and after these 3 years, this is not the same CPO that has been selected to continue to operate this. So thanks to PKI, it's possible to download within the charging station certificates dedicated or owned by the new CPO. So this is a way where we are managing the change of ownership. For devices that will leave one activity to a new one, this is the same things. In terms of security mindset, I'm just talking about cybersecurity. So we change the secure identity of the device between the first life and the second life. It can be also something that we can apply to the battery. In the battery, we may have certificates belonging to the car OEM, for example. And after that, if the battery is used for another usage, it will be possible to onboard in the battery new certificates in order to prove the ownership of these new operators or owners.
Okay, thank you, Gilles, very much
Thanks
for the
a lot.
presentation. Okay, now we move to the first round table of our day, which will explore the progress made so far for interoperability and what are the future challenges. For this, I call Marion Arles, which will be our moderator. Please, Marion. Marion is the innovation team leader from GREF. She comes with 15 years of experience supporting various energy companies. Please, Marion, the floor is yours.
Okay. So, good morning, everyone. So, as Hussein said, I'm working at GREF now. Jean-Marc already introduced GREF a few minutes ago. We are an interoperability gateway for the mobility sector. basically, we provide roaming and plug-and-charge services for the e-mobility sector. And today, I would like to introduce, and I'm really pleased to ask questions for this roundtable. So we will talk about the last progress and the future challenges for the EV charging interoperability. And just a few words to introduce this topic. In such a global industry at the EV market, we can say we all know that interoperability is a must. But if we looked at the history in each and every industry, especially in transport industry, the fact is, and the facts show that interoperability, if you don't pay attention to it, it's not coming spontaneously. It's not an easy journey. It's not self-evident. So interoperability is never a matter of choice. It's always the result of a long and painstaking work, bringing together a lot of industry players, regulation bodies, technical engineer, normalization and standardization bodies. So it's never spontaneous, but it's obvious that we all need that. So it's really important topic today. And a lot of progress have been done in the EV sector, especially for public charging now, today, but many things remain to do. And that's why, to talk about this topic, I'm really pleased to introduce the panel today. So who better than the panel of the speaker that is assembled here today? They are, for some of them, car makers. They are charging point operators. They are e-mobility service provider. They place critical roles for the EV charging industry and the smart grid industry by developing, promoting, and certifying standards. So, and they are really involved in the many regulation bodies, many regulation discussion, many normalization working group. So please, let's welcome the panel of speakers. Okay, I will introduce. So Michael Keller. Okay, Cor Melker, Didier Deruy, Zi Zhang, and Régis Ledrezen. Okay, so let's introduce this topic of this roundtable with you, Michael. So Michael Keller, you are a Chief Technology Officer at Charing. Charing is an organization that is focused on developing and promoting standards in the charging infrastructure, especially including the famous CCS, the combined charging system. You have over 22 years of experience in the automotive industry, being both sides, supplier side and also car maker side. And before joining Charing, you also have been involved in the Volkswagen Group, and you coordinate the development of a project where there was interaction between the energy sector and the charging infrastructure. So this first question is to you, Michael. So just to introduce this topic, how is Charing driving progress in the EV charging interoperability, and what are the current topics? What are the hot challenges? Who are the key players?
Yeah, thanks for the kind introduction. There are a lot of really big questions. I try to answer them one by one. So first, what Charing is doing. Charing is doing support for the community on different levels. Yeah? So I think the key why Charing was founded is to have a framing where all of the industry players can talk together about how they want to describe and develop the future. Like you said, interoperability is a key, and to make that all working, you need to talk a lot with each other. And it's not only that you can use existing associations of an industry area, you have to have here for charging a huge variety of different industries and companies who need to talk together and need to align, need to agree on common technologies, and that's exactly where Charing gives the frame for. And also with our members together, we are then supporting that these agreements, these ideas, and also specifications are then going into the standardization, because at the end it must be clearly defined and written and accessible for everyone to have the level playing field for the companies to make the solution on the aligned standards for charging around the globe. Yeah, what topics we have? There's a lot of hot topics right now. We have already talked about one thing I really like to talk about. That's plug and charge. That includes also roaming, and now we can also include multi-PKIs, which also enables that different providers of PKIs and also different providers of the MSP services are able to offer that in a wide range, and also globally we want to do that. And also there is still a lot of work to do. We already talked about, so Cora and me, about the need, what we have also heard today about the OPNC. Yeah? It's existing, we have published it from CHAR in beginning of the year. It was, I think, March timeframe. And this is just a starting point, because that was the first time that also for PKI and for the ability of PKIs we have a common protocol. But there's still room for improvement to make it more efficient, to make it on a broader scale. And there, like also the two colleagues from Sheriff and Hubcheck did ask for support. So we are open. This is an open discussion, so that everyone who has an expert who want to support the further development of OPNC as the protocol for interoperability of PKIs will be developed further. And I think that's a key again. And this is just one specific topic I want to mention, but also if you look on a global scale, we have also big discussions in the North American market about NACI. There also, we from CHAN have established 5 different task forces to bring also beyond what's been done in the SAE for the connector, because you have a complete system to be redefined by changing a connector with a different communication and so on. So this is also a huge topic. We are also, together with our North American members and also global members, are supporting these task forces are working on. That's just two big topics I mentioned. I could continue the list, but I want to leave also the floor to the others.
Okay, thank you. Thank you also for the others. I'm now turn to you, Xi, just to introduce the challenge of the interoperability from the perspective of a hardware and software development player. So Xi Zhang. Okay, thank you. You are the director of e-mobility of the scale-up company ECOG. You are driving effort in the e-mobility community to provide standardized and interoperable solution, and in particular you act, for instance, at the ISO level for the vehicle-to-grid interface. And you're also involved in a lot of focus group within a charring activity. So this question is for you, Xi. How does ECOG handle the development of hardware and software for EV charging solution, especially when standards are still evolving?
All right, thanks a lot for the introduction and question. For those who actually don't know what ECOG does, we primarily provide charging solutions. Basically, the solution sits within the charger. So we take care of automation in the charger, we take care of interfaces to the vehicle's interface, to the CPO backend. So as you know, there are a lot of interfaces, so of course interoperability is one of the key challenges that we face every day. And I agree with you completely that interoperability doesn't come by default. It's a painstaking journey for everyone. And we are still on the journey. And in this case, because interoperability by definition is not something that we can do ourselves. It's not that, oh, we are a brilliant company and we know how to solve the problem by ourselves. So we take, I think the key here is to actually be involved and contributing as much as you can to the ecosystem to get everybody kind of work on the same topic together. So in this case, we actually, as mentioned, also introduction, and we actually take charring as a vessel to help us to kind of improve the interoperability in the market in our solutions. For example, we know that Dash 20 has been published, and then there are a lot of, let's say, industry interest in developing Dash 20, but it's a very huge document, and there are a lot of things which are not clear. So then within charging, we started the focus group activity to kind of write an interoperability guide on how to do DC bidirectional charging using a standard-based solution. So, and this has actually recently been published, the second version. So this is kind of the effort that we make within the industry to help to kind of have a solution towards a common goal. Of course, there are specific things like how to make software solution over the air updatable, and how to make your hardware solution more kind of modular so that you can also update it when there is new applications coming up. But those are more obvious. I think the main effort or the key message that I want to say here is still that be involved in the ecosystem and be contributing and be the one who set the pace. Together with your partners and your competitors. I mean, we work with our competitors all the time, right? So, because we believe that this is the way to go to kind of achieve interoperability. Yeah.
Okay, thank you. Thank you for this introduction. I would now, I would like to look at the smart grid perspective, because a smart grid also drives numbers of new innovative use cases, so numbers of new data exchanges, new players, new challenges. So Régis, okay, this question is for you. So Régis Le Drezen, you have made an over 24 years career within the EDF group, first working in the transmission entity that is now called the RTE in France. And then you quickly joined the distribution entity that is now called the Enedis, which is the main French distribution system operator. And in 2011, you became the technical director of Smart Grid Vendée. For those who don't know, Smart Grid Vendée is one of France's most ambitious smart grid projects. In 2018, you transitioned from the director of Enedis Région Vendée to the strategic Enedis project in mobility project, and since 2022 you are now the general delegate of Think Smart Grid. So from the smart grid perspective, with the rapid evolution of the smart grid, how can EV charging be efficiently integrated from this perspective?
Thank you very much, Marion. Think Smart Grid is a professional non-profit association which represents the entire smart grid ecosystem in France. We have a lot of members coming from the energy sector, the digital sector, and now the automotive sector. And I'm very pleased to announce that VEDECOM is a member of our association. It's very good news. Before focusing on 3 key messages on the how EV can help the electricity system, just to remind that to succeed in decarbonizing our economies, we need to electrify a lot of uses as EVs, and we need to deploy a lot of renewable energies. In France, our electricity currently amounts 25% of the final energy consumption, and this figure is set to rise to 50, 55 to 60%. So consumption will play a crucial role in the balancing electricity system. So now we can focus on the EV part. And the arrival of EVs is a new opportunity for the energy sector. It's not a constraint. Why? Firstly, because with smart charging, it's possible to urge EV owners to charge their vehicle outside peak hours, only with a simple price signal. with the management based on peak and off peaks, they will reduce their bill. Secondly, moreover, controlling the power of the charge by modulating it according to the power total of the house, the end user will make other saving on the grid too. And thirdly, combining smart charging or peak off-peak hours with wind and solar generation, it will reduce local peaks in demand. It will reduce the backflow of the electricity generated by renewable onto the transmission network, and it will reduce electricity losses. So, to summarize, EV is a main lever for absorbing electricity generated by renewable energies.
Okay, thank you. Good program, great introduction. I would like to see the topic of interoperability from the point of view of a charge point operator. So, Cole Melker, yes, you're right, this question is for you. Cole Melker, you are Director of Global Standard of Charge Point, covering both Europe and North America. You've been active in the e-mobility domain for 10 years. You lead a team of standard engineers that are actively working on various standardization committees, such as the Open Charge Alliance, the EV Roaming Foundation, the CHARIN working group, the ISO, IEC, and the ACE-AE. You're also very active in the governance and implementation of standards, and you are one of the experts of the Sustainable Transport Forum, which advised the European Commission on several topics like PKI, plug-in charge, and smart charge. So the question is, what role do you see charging point operators playing outside of public EV charging? Because a lot of progress have already been done in the public charging domain for interoperability. But now, if we look especially in the area like workplaces, residentials, or fleet.
Yeah, nice question, especially in regards to interoperability. Yes, I'm working, we are, as a team, we are blessed that my company has given us full-time access to develop standards, and that's really important so that you can keep the focus and get the whole overview from driver to car and everything in between. And so you also see, hey, when focused on one protocol, you missed maybe the other one. This helps me a lot, getting those overview. And when you're looking at interoperability in the case of what does a CPO do, because ChargePoint is, as one of the tasks, is a CPO, or supporting CPOs, because in fact we are not a CPO, but our customers are, but we are running their software. If you look at that in the case of interoperability, you want to have the same experience on your workplace, on your home, as in the public. So it should operate the same way. So to guarantee interoperability that your card works at your workplace, but also at a public station with the same performance and the same quality, then you have to have operators that take care of that. Of course, you can do it yourself. It's just an electric device, you plug it in, get power on it, and it will charge your car. But then you have to organize everything yourself. And what we see happening is that, especially those fleets, leasing companies that give you a car with a charger at home, they take also care of running the charger, taking care that the charger is up to date with the latest security aspects, with the latest software stacks. Also in workplaces they take care, but also an important one, if you have a fleet with company cars and they charge at home, they want to get money back for the energy they supply to that car. So the whole reimbursement has to be taken care of. So they have to measure stuff. They have to see how can we balance, get the cheapest energy in the car for the driver. And that maybe he plugs in at 6, but start the session at 12. Because the market is then cheaper. So yes, I think the CPOs, the operators, take care of all stations. If they're public, semi-public or private, doesn't matter. They run it the same way. As I was working previously at another company, we were saying, we run all stations from 3.5 kilowatt up to 350, and maybe I should have said now 1,000 kilowatts. And it's just running protocols, standards, and govern them correctly, and then act the same way, and taking care of the driver that he can plug in and charge anywhere.
Okay, thank you. We already talked about a lot of issues, about some innovative use cases, about the technical aspect of interoperability, about the need of all the actors to discuss together, but we didn't talk so much about the regulation, still not yet. So Didier, yes, you're right, discussion is for you. Didier Deruy, you are a 100% automotive engineer with 30 years experience, including 24 with Renault Group. You've been working already 16 years in the EV domain, because you were the project leader of the first EV battery assembled by Renault, and already 9 years in vehicle to grid, from the research phases to now the world first class mass market introduction of a vehicle to grid green AC Renault 5. So you are now expert leader on charge ecosystem with Ampere, and Ampere is a sub company of Renault that is really focusing on the engineering, electric vehicle engineering and production. So yes, DJ, this question is for you about the regulation. With the launch of the Renault 5, with its AC V2G capabilities, what are, according to you, the major regulatory challenges, especially those that are grouped under the name of grid code, DOS related? What needs to be addressed on that domain?
Yes, the major concern is clearly grid code. So I will have to explain a little bit what are grid code. Grid code are technical requirements all generators must fulfill to access to the electricity network if you are above 800 watts. So it's classified depending on power capacity. A nuclear plant is a type D generator. A home solar inverter is a type E, and we discover that a V2G car is a type E generator also. So in the automotive industry, we have the habits about technical requirements. All cars must fulfill technical requirements to be allowed to be registered to access to the road network. It's called homologation. So we consider it was exactly the same for the electrical network. The main difference is for homologation, it's harmonized all across Europe. If we do the homologation, for example, for the Renault 5 in France, you are able to register and to sell your car everywhere in Europe, and even above due to cross-recognition of the European homologation. If you go for grid code, it's completely different. It's local, generally by countries, that you must be grid code certified for each country. So, for example, we are certified for France. We are under certification for Germany, and considering UK, and each country, we have to do another certification with, let's say, slight different interpretation of the regulation or the standards. And it's really difficult and tough point we have to implement. It's very difficult, let's say, just to design a car that is able to fulfill every grid code, because we discover each time a new requirement, a new asset, a little thing like that. So that's the challenge for the car makers, but I should say there is another challenge for the DSO. For the DSO, generally when you install a generator, it's the fixed equipment. It's not moving at all. So you can describe the installation you will do inside the home and get the approval to inject energy with this installation. When we come with the V2G, we have a fixed equipment, the wall box, but we have a moving inverter because the power conversion is inside the car, and that's something completely new for the DSO, that you will install something that is moving from home to home, from country to country. So for them, we have to adjust, let's say, the procedure and process for installation to agree that we will install a wall box that is the only fixed equipment, but that we will certify both wallbox and cars, and make sure that we will fulfill all the grid code with the two equipment at the same place at the same moment.
Okay, a good illustration that effectively interoperability is not an easy journey. There are many challenges. So regulation is key, and so does the standardization. But not only at the European level, because the industry is global. So we have to look also worldwide. So Cor, this question is for you. As the charging standard evolves, what are, according to you, the key challenges in harmonizing the EV charging standards at the global level? How is ChargePoint working on that topic and addressing this variation across the different markets?
That's a nice one. Because within harmonization, you have to harmonize a lot. Let that be clear. You start in local requirements, going up to regional requirements, country requirements. Mentioned already about grid codes. Going back to continental, like European codes, and then the American, North American that think European codes are not right, so we do our own. That's the way to think. And then working for an international company operating in North America and Europe, you are confronted with that. So it's a big challenge. It takes a lot of effort and thinking, a lot of talking, a lot of lobbying, and also writing down to try to get all those requirements together and to find a way that standards and protocols can accommodate all the variations. Because that's the thing. Protocols should not say what you have to do, but they should support what we want to do. And that's the big challenge. You have to find how optional, how far do you go. And that's what you see with the new protocols. They're getting more and more complex. Was already mentioned, 1511.8-20 is a huge document and it's almost unreadable. OSPP is also 900 pages. Go ahead and implement it. So the protocols grow. And therefore, yeah, you have to adopt them, get into them, and try to implement them while working on it and find it the way. And adjust to harmonization as possible. But it starts all over again every time. For charging, we have the Eichrecht in Germany, brings up a new challenge. We have now reporting charging stations to all kinds of database registers like the National Access Point. Every country wants their own database fields in there extra on top of the ones that are already planned. Nice for a company working in Europe, addressing 27 databases with your charging station information with 27 sets of APIs in 4 different architectures. Start working on that, so we start to lobby on a Europe thing. So what helps, and I think that's my challenge, is that I'm involved in all of those. Some people saying, I see you everywhere. Yeah, that's true, because I have to be everywhere to get that aligned. And I think I have a big success currently happening is within SDF here in Europe we designed the PKI ecosystem. America was not doing anything. In America they started with the consortium to do the EV PKI with SAE. And they had to do the same thing as they've done in Europe. So I gave them over with permission of the European Commission the design we have made here by SDF and saying, here you have a template which you can use to start up your implementation of your ecosystem. And I use the term template, especially because I don't say it's a standard from Europe and you have to use it. No, I said it's a template. You feel free to use it. So I gave them the challenge. And they, the policy authority took it up and said, this is good, we're going to use it as is. And so America is now developing their PKI ecosystem based on the European design. Now my challenge comes back is when they are ready, hopefully beginning of next year, I come back to Europe and say, we have it built already, just implement it. So that's how you have to do. It's a lot of effort, a lot of work. Michael can phrase that. If you're lobbying, you're working in this domain of standards and getting them interoperable and getting them harmonized, you have to be there. Do the discussions. Open your mouth and start writing.
Yeah, that's exactly the problem, yeah? You have different organizations in different regions, and then you have sometimes also regulatory in different nations, yeah? And to bring this zoo of different kind of thinking together to make one solution, that's what you mentioned, how difficult it is to make it interoperable. You have to agree on a common standard or a common template, whatever you call it, to make it politically acceptable. And that's exactly where we have to put all together a lot of effort into. And that's really what Kurt just described is really the center work we have to do to bring it forward.
Yeah, and so I'm not only an engineer anymore, I'm also a political guy who has to start talking on that level. It's part of the job, but luckily I'm the one with most knowledge, so debates are easy.
Okay, thank you for this very practical illustration of how interoperability has to go, how you're working on that. It's very practical. So going in that direction of practical deployment of EV charging interoperability, let's talk about, I don't know, some planning, some roadmap, some future coming milestone. I have a question about the CCS standard and being a reference. Can you share, Michael, some insight on the promotion of the CCS reference standard and introduce also the topic of the MCS upcoming standard?
Yeah, what we can say is that the good thing is that MCS was very much based on the experience of several thousand engineering expert time from the CCS development. So CCS is developed very well, and we have also included in that also communication. We already have talked about the ISO 15118 standard, which is part of the combined charging system, because it's a system you need to develop, not only one standard. So CCS is deployed in about at least 7 different standards you need to put together, maybe some more parts you need to implement to make it work, and that's really the core what we need to do to keep that all aligned, and do the same what we do over the globe. We need also between different standards, we need to align them to a system. The same what is now going on in North America with the North American charging system, and we did the same with MCS. So MCS was started in 2018, where we had a small group of people meeting in California, it was, from the truck industry, and say, okay, we need to do something different, because CCS has some limits because of the physical design of the connector pins, which are right now in the range of, I heard different numbers, but so around 500 kilowatts and only 350, so they can some even do more with appropriate cooling and for short-term charging. So this really still parts to be developed and to align in a way that the standard is allowing and supporting such high power on the CCS charging. But on MCS, we wanted to go then together with the different industry partners, with a group of more than 110 companies together to develop a standard going up to 4.5 megawatts. And the thing is now that the further development you were asking for is that these different, or these specification, which was done commonly in this project of MCS inside of Charin, is now being brought into 5 different standardization bodies, where now the standards are defined for communication, for vehicle side, for infrastructure side, and so on. And they are coming now to the end step by step, so they will be published, the last ones, end of this year, maybe beginning of next year, so then this MCS standard is ready to go. But we are not stopping on that. In parallel also, we have inside of Charin a dedicated group who's talking about how to use a charging system based mainly on MCS for other industry areas like mining. Mining industry is a big chance, because they are, we have to say, polluting about 3% of the global CO2 emissions, yeah? And if we can reduce that, and the potential is if all these big, huge, few hundred-ton trucks also to electric trucks, and we have seen just a few weeks ago the first Liebherr truck with, I think, about 200 ton of BESS to move around. And they have prototyped the first mining MCS application on such a truck. If that's something what can be changed globally, and this development is ongoing, because the good thing is, same with the truck industry, they make calculations. When is a break-even point to change to electric trucks or these big machineries? Then the controller says, okay, you have to do it. Yeah? so it's not to have to motivate people to go for electric car and show them the drive performance and things like that. It's just by rational, by the maths of the numbers. And if we can support with churn and this project, this change, there's a chance of reducing in the next few years, depending on how fast the reproduction and of the electric trucks and the exchange of the existing ones are happening, of a global CO2 emission of about 1.5%, which is a bit less than what has been done right now in Germany as a CO2 emission. So it's a huge impact based on the numbers for global impact, and that's what we're supporting. And we are not stopping, we are continuing also to other industries. First things are with the marine industries, so for ships and vessels, and we are now preparing also from China. We have first discussions about how that can be done also in the aerospace industry.
Okay, thank you. Going further in this step-by-step practical deployment of a new charging solution, a question to you, Didier, about the next step of the Renault 5 V2G capabilities. Practically, is there a plan to open your solution for interoperability for other business cases?
Yes, as explained, for our customer, interoperability is a need. It's not critical for private environments, it's nice to have, but it's critical if you go to fleet, to works, when you can have multi-brand access, and clearly a must for public charging, where it's interoperability is key. So we have to be interoperable. For the Renault 5, we are not completely today, but we'll explain a little bit, due to the fact that the standard was not completely finalized about these topics. And if you want to be the first of the market, you have to interpret, you have to define your own implementation, expecting that it will be the implementation the other will follow. Let's say like that. So that's what we did for the Renault 5, but we take the state-of-the-art standards. We have since a long time defined what we consider to be the function allocation about what the wallbox should do, what the car should do to fulfill the services and to fulfill the grid codes. We work on the ISO 15111-20 to be able to support this functional allocation and offer the services, and we did the completed implementation. The good news is, in fact, we are already very close to be interoperable. The car is one of the first to implement ISO 15111-20. We defined the car to be compliant with the wallbox you have there, that is our wallbox to do that. But we did also test with other company, and here you have a VEDECOM wallbox. The car is a production car coming from the factory with its all this software serial, cyber security activated, TLS. And we are able to open a V2G station with a wallbox that is clearly not defined to be compliant with this car, but just implementing ISO 15111-20 by the correct way. And you will see during the launch, if you want, that we are able to do V2G without any concern like that.
Great news. Regis, going back to the smart grid and also the roadmap, what are the next steps? So you told us that the EV was a key asset for the smart grid. Okay, so what is the roadmap now?
Maybe my my answer could explain a few interrogations that Didier and the automotive sector have. After having explained that EV can help the electricity system, we must to be aware now that this is a collective affair, of course, and that all stakeholders must to work together. So why? Very simply to understand. If we continue in the same way to develop the use of flexibility in France, there is no chance of succeeding, no chance. So what is the key to success? After explaining and educating the end consumer, and it's of course very, very important, we absolutely must standardize data exchanges. And it's the first time that we would like to tackle this topic. So I want to speak to the link between the electricity system and the EV chargers, and the electricity system and the EV itself. So my message is to commit the actors to develop IT platform management able to interface with 3 actors. First, electricity suppliers, then commercial aggregators, third, TSO and DSOs, as explained by Didier. Because to manage the EV charge, you can do it and arbitrate with data. For instance, the price of the electricity in euro. Other example, the information of CO2, if you want to consume green electricity. So I would like to share with you an information. We are going to publish a white paper in a few days named Plan for Scaling Up Flexibilities in Buildings, Technical Recommendation from Smart Grids France sector. Inside you will find a strong recommendation for developing technical recommendation for energy management system in buildings named BACS. BACS doesn't mean Building Automation Control and System. And our final objective will be to tackle all control system, and of course as electricity, EV chargers or EV energy management system. So we are ready to tackle the problem of the grid code and interoperability between the electricity system and the ecosystem from EVs.
Okay, thank you. With you, Regis, and you, Didier, we just have a great illustration of, the regulation is key, standardization is key, but the ecosystem can't wait. So we have to build the first step. We have to propose some position, and we have to start building. Even if, we are all aware that the regulation and the standardization are really key assets when it comes to a large-scale development of innovative things. But let's start with what's the real life. So a question for you, Cor, about the de facto standard. How does ChargePoint view the role of the de facto standard in the EV charging ecosystem, and what strategy should be in place to integrate them into the formal international standardization bodies and processes?
Nice topic, talking about de facto and de jure standards. What's the difference and why the hell are we talking about this? Going this way, if you're looking at the standards, we embrace fully open standards, let that be clear. Open standards developed by industry for industry is the way that it's initiated. Many protocols are initiated by some companies. We have to work together and we start writing down how do we exchange. And those protocols developed, standards developed into big protocols like OSPP now did 10 years ago. It started off with 3 companies and it's now worldwide the charging management protocol. So that's what we fully embrace and also join those groups to start writing that, being myself co-writer of many of those protocols, I fully embrace. But when we're facing it in the rest of the world, it's easy, they don't bother. If it's developed by SAE, if it's developed by ISO or by OCA or by the EV Roaming Foundation or by Charin, they will accept it and put it in their regulations. In Europe, there's something different. The European Commission, in all its wisdom, decided many years ago that they only accept standards that are written down by IEC, ISO or ETSI. These 3 organizations, they are developing standards, and that's controlled by 2 organizations called CEN and CEN-CENELEC, and that's where the name de jure comes from, because if you're not one of those standards, you cannot be accepted and put into regulation. That's a big issue. So ISO 15118 has it easy because it's developed by ISO, but like OSPP, the next step you need to go up, and later on OP&C. We can develop it by industry, but we have to get it approved by IEC and get a number. And that's the big difference. So what does it do? What I've seen the last years is that I was developing 2 charger communication protocols. One called OSPP and the other one called IEC 63110. 2 equally protocols, spending a lot of resources on those few experts around the world that can define such a protocol. They had to do both, because you have to be as closely as possible together, or as I'm sometimes saying, do damage control to prevent the other one is going away from you. So that's a lot of things. So yeah, I think it prevents innovation, it prevents industry acting, and the other hand, yeah, we have to agree on some standards. So what we are doing now is, involved in that process, is getting OSPP being approved as an IEC protocol, and we will follow the next step also with OP&C, and I believe there the route is via ETSI, but also with OSPI, the roaming protocol. There we're also talking. So it's now, I think, end of this month, it will be decided if we are approved as a de jure protocol, being started as a de facto standard. So let's see what happens. So everybody has the chance to vote yes, please do that. It's the IEC 63584, vote for yes. So OSPP will be the standard also in Europe, so everywhere in the world except China.
Okay, and following the same idea of retrofitting the things or re-engineering things, I have a question for you, Xi. Because there is a challenge about the ability to retrofit and update things that are already deployed with the new standards coming and the new regulation coming, because for the moment they are not finalized. So how can you face this challenge of ensuring the retrofitting of things?
Yeah, thanks for the question. So actually, I mean, recently we do have quite a lot of people coming to ask for help to retrofit their stations that is in the field. I think most of them, let's say, started in the early stage of e-mobility infrastructure development, and they did everything from scratch. I think that's what Stefan mentioned. So in the very, very early stage, everybody did everything from scratch. So of course you can have full control, but then as the standard gets more complicated, as you have more, let's say, secondary actors coming into play, the things becomes not manageable. So I think that's why in the industry there are companies like Ecog and alike who are then providing more, let's say, a socialized solution for all the solution suppliers out there, so that they don't have to do everything themselves, but they can focus their energy on what makes their product unique. So that's one thing. That's kind of one thing is to let the let's say, domain experts do that part that they are good at, and not to try to do everything yourself. And then on retrofitting solution itself, I guess separating, let's say, hardware and software. So from hardware perspective, it's more providing a standard reference design to the systems so that you don't have to change too much when you have a regulation change. So, for example, if you are upgrading or, let's say, retrofitting your CCS station to an MCS station, I mean, I think there are a lot of companies who actually want to do both. It's kind of, if you do have a solution where you kind of already modularized your power electronics from your control system, then it's relatively easy to kind of upgrade only part of your system, while the control part is more kind of, if you have a good hardware abstraction layer design, and then you just have to design a new driver model for the new power electronics to, let's say, fulfill that part of requirement. And then, so is with, let's say, controller hardware perspective. So we know that for MCS, there are things which are, let's say, similar to CCS. So you have to do 15.8-20, but then you have also hardware variations where you need to do a different, let's say, control pilot handling, and then you have a different physical communication layer. So then it depends on if you have already designed your, let's say, control hardware in a modular fashion, where you can keep the core part where the logic runs, still stay as it is, and then you have the separate, more, let's say, protocol-specific part as an add-on module so that you can change easily. So that's what, I guess from hardware perspective, what you can do to kind of ease the journey of retrofitting. And then from software perspective, as mentioned, is kind of having a good driver model for your system so that you can easily, let's say, exchange stuff, and also definitely ensure remote software updatability so that when you know there is a new standard coming out and there is minor, let's say, adaptations compared to the draft version that you have implemented, which I suppose, like, for example, for Renault 5, that would be the case, that the solution is implemented based on, let's say, not finalized version of standard, but it's a small deviation to the standard so that when you want, you can actually just do a software update to the system so that it's fully standard compatible. And having this kind of software update kind of system available is then another thing that is kind of essential to be able to keep your system running in the field. Yeah. Thanks.
Okay, so that makes a lot of challenges to address, building the ecosystem for tomorrow, but also starting building it from now. So many things to tackle. Finally, maybe a last question, but because time is running, and I would like to give the floor to the assembly here, just to ask some question. But a last question, because in fine, this global need for the energy transition and the resulting boom of the EVs that are coming on the road, that's really radically changed. In fine, that will radically change the way each individual will tomorrow move and live. So maybe from the end user perspective, how does Ampere plan to overcome the barrier to the end user adoption of new services, and what strategy will be in place to increase their engagement in that system?
Yes, it's clear. We try to define our services as if we were a customer. So the first things we have done, there is 4 pillars about that. The first pillar is mobility first. If you purchase a car, if you purchase a Renault 5, is to comply with your mobility needs. And you agree to have, let's say, smart charging services if it's comply with your request. I mean, if you get every time the level, the state of charge you expected at the time you expected. If you are able to fulfill that, if there is room for energy services, and there is, okay. But first my mobility needs. And we design the services to make sure that it's always the mobility needs that are first. The second thing that might seem surprising is for the customer, V2G is free. For the Renault 5, all the Renault 5 has a bidirectional onboard charger included. Due to economy of scales and reduction of diversity, it's comprising the price of the EV. It's not an option you have to purchase. All the cars are V2G ready. The second thing, wallbox is free. Today, like every car makers, when you buy an EV, we have a commercial offer to offer you the wallbox. And of course, for the Renault 5, the wallbox will be the offer. It's the Verso that is here. It's the one that is V2G AC compatible. So you don't have to pay for it. It's offered as a commercial offer to buy the car. The third thing, when you subscribe the services, the subscription is free. So you absolutely have no money to pay to access. And even if you don't subscribe at the time you buy the car, you will be able to subscribe later on because the car is ready, the wallbox is already compatible, and you just have to activate the services. The third thing that is very important, the services is simple. We won't explain to our customer what is electricity wholesale market. No, what we need for our customer is to plug their car as many times as they are back to home and to let us access to their battery and do the business pivot. So we decided to have a system that you be paid for the time you let the car under a V2G session. Whatever the car is doing, it can do nothing and you will be paid. It can do only the charging and you will be paid. If you plug from 8 in the evening to 8 in the morning, you will have 12 hours counted as V2G session. And the final thing, because everybody is wondering about that, is we include, of course, the V2G, but the battery warranty. We designed the battery to be to fulfill these new services. We designed the services not to be allowed if the battery is not in situation to support it. And it's clearly transparent in terms of warranty. You have a complete warranty with the V2G. So V2G is only for the customer a win-win solution. You don't have to pay for. There is no compromise with your mobility needs. It's free from everything, and the only risk you take is to have your electricity bills for charging reduced by half. That's what we expect to be the success of this offer.
Okay, yes, yeah, for sure. We can wish you very good success for that because, yeah, of course, I want one. And I'm not the only one. Okay, maybe I think we still have a few minutes, just 2 minutes, sorry. Okay, yeah, he's right. So maybe a few questions for the audience here. Do you have any question for any one of the speakers?
Thank you very much. So first, thank you for the presentation. It was very interesting. So I'm Mariam Naimi, Standardization Development Manager at AFNOR Normalisation. So it is the French National Committee. I'm very sort of pleased to hear the standardization in sort of the middle of the discussions today. So that confirms I'm at the right place. So my question is maybe for Cor Merkler. Sorry if I'm pronouncing wrong. Today, standardization is at the crossroads of all these themes we've been listening to since this morning. So I can sort of cybersecurity, for example. It was mentioned this morning, and it is very tied to regulation. So at European level, at least. So today, the assessment conformity is obtained through standards. And what is important is for experts today of all sectors to participate to this process of drafting these standards in order to be as close as possible to the technical sort of requirements today, in order for the regulation to impose compliance correctly. So should we today think European for EV, or should we expand international? Because today we have a set of regulation at European level. For example, the digital product passport, we can think of the cyber security resilience, or many other regulations that are coming that are going to touch upon the grid, TSO maybe. So we can imagine regulation at European level that needs focus from experts at European level. So what do you think, as also experts of the matter, should we have European focus, or should we think international today? Thank you.
Nice question to ask me, operating international for North America and Europe. So my preference is international standards. Try to get them as equal as possible. And yes, all the aspects you mentioned, like security, cybersecurity, interoperability, the thing. Because companies get more and more international. Car manufacturers, you get cars from Korea, from Japan, from China, from America, from Europe, all driving around in your area. So they have to communicate in all continents. Charging operators, like my company itself, is running in North America and Europe. So we prefer to have one system running everywhere. So we prefer also to have one set of standards that everybody works with, because it costs already so much money and resources to develop standards and to get them implemented correctly and certified. Why having then different ones in the different parts of the world? Because then we have to do double work and double money. And it's already costing a lot of money to get this off the ground. So I would go for international ones and standardize them worldwide. But yeah, it starts in a region. Like here, my counterpart, Renault 5, found a solution, had to adjust the standard. Hopefully they will bring it into the working group and it will become part of the standard. And that's how it works and how it evolves.
Thank you. Okay, thank you. I think the roundtable come to its end. So if you want to ask some question to the speaker, probably you will be able to do it at the lunchtime. So Hussein, just tell us what's next.
Thank you, Marion, and thank you for the speakers. Really very interesting discussion, and I want to note that some of these topics will be developed more during some presentation after the lunch that we will take right now. So enjoy, refill your energy, and let's come back.
I have this mic.
Okay, because I will be in the car.
Yeah, I will come
With
down.
one hand, I will have the phone.
Okay,
and the other
I will
hand-
get it for you.
Yes.
Okay. Yeah.
Just to look for what they decided as a dog, they want to make the first test.
Yes.
Which one is good? They want to try
Yes.
to try to better than this.
Yes.
So they can
Does someone from them want to moderate it, or shall I moderate it?
No, you moderate
Okay, I will do some research.
Then if it works the second time,
Yes.
if it does not work, take the lead on multiple tests.
Sure. Yeah, I will do the end, like just finalize everything. Okay. Who is calling to order? Okay. He's ready. He's ready.
Hello again. Please be seated so that we can resume our presentations and demos. Everyone, please be seated so that we can resume our presentations and demos. Thank you. Okay. I hope you had a nice lunch and some coffee to continue this long but very interesting day. Personally, I was waiting this presentation because I was following the steps of Stefan, who came from Munich by car to here. So I was hoping that you arrive safe, and you arrived. That's good. It took, I think, 10 hours. So join me in welcoming Stefan Renaud, who will be presenting a plug and charge showing multiple contracts in action. So please, Stefan, the floor is yours.
Hello again. Yeah, so until the slides are coming. So in the Mobena project, we were discussing what kind of topics should we discuss inside the group, what is important, and multi-contract came to place, and I was like, maybe we shouldn't discuss like how we can start from scratch. Maybe we should show what's already available in the market. And so we decided we just got a serious BMW from them, from BMW, and we drove it over here. So you can buy these cars. So it's not a demo, like it's not a test, it's a demonstration of what's currently in the market. So the presentation is really like to made for you as a user. So if you have this car, how to set up a contract. If you're an OEM, of course, now not 20 OEMs are here, but some OEMs are here, and we discussed this already. What should you do to provide this customer journey? And of course, for the EVC manufacturers and CPOs, what does it mean for you if a car can come with multiple contracts, and for the mobility operator, because this is a big chance for every MSP to be installed in a seamless way into the car. So This slide you remember maybe we had before about the big issues or the big topics we need to discuss and discover in Plug and Charge, and one was multi-contract handling. How does it work, and is it actually working already in the market? What is multi-contract? It's the relation from one car, which is in the ISO, a PCID. A PCID is defining the name of the car. It's mostly the VIN number here in the BMW, and the contracts which are available. So it's possible to connect one PCID to multiple EMIDs. So you have multiple contracts for one car from different MSPs, even from the same MSP, maybe one private charging and one company charging. This is possible and can be connected. It's about the user journey. We need to see that the user is capable in creating a contract with the MSP app and can select them in the vehicle or in a vehicle closed HMI like an app. So where are we, like what is the current, let's say, understanding, interpretation, and what is reality? And the interpretation is mostly, and people approach us since years, multi-contract is not possible with ISO-2. This is not true. The ISO is just saying in one session, one contract can be installed in a car, but it's not saying one contract is it's just allowed for one car. So as I mentioned already, most OEMs are going to be telematic connected. So if you create now multiple contracts for one car, the car can just install them over the air and you can show them literally directly in the car. Of course, we know in the -20, in the update of the norm, it's possible to install also multiple contracts over the charging station, but we need to wait until we have -20 in the market really rolled out in a wider scale. And I already see that most OEMs are switching the habit to be multi-contract capable, even if they started single contract. One example is Porsche. Porsche started in 2019 with Plug and Charge rolling out with us. One contract, Porsche charging service. I think you could say it's a Porsche driver. Maybe they don't care about the pricing. But now in the new Macan, it's already opened up. So you can choose your contract for the Macan. So you see even the change of the OEMs. And it takes time. Automotive development, again, it takes, unfortunately, time. So here we need to be a little bit patient with the OEMs, and we need to create some force that they do it, but they will do it anyhow. And here I added some links for like kind of the proof that it's not that it's really reality. Like BMW is doing this since last year, VW is doing this with the whole group. They are Skoda, Audi since 2 years already, and more OEMs will follow, without or with regulation. So these are it's the landscape, at least for us as subjects. These are the OEMs who are already working with us. Not all of them doing multi-contract, to be really frank here. Some are in the development phase. But you also see a lot of MSPs which are not tied to OEM, which is important. At the beginning, it was always like an OEM is choosing an MSP, done. And then the other MSPs were saying, hey, why should I do Plug and Charge? I'm getting locked out. But with this implementations now, every MSP can be installed without having any contact to the OEM side, to the left side, and can be mutually installed without any regulation. The CPUs on the bottom part for US and North America and EU and even Korea. We have now some Korean CPUs are also understanding that this is the key feature. So how does it work? And we will show this in a bit in a real scenario. We have a role play prepared. So the customer is getting the PCID. The PCID is a number which is describing the car. As mentioned, BMW, VW takes the VIN number. So you just read the VIN number and you enter it in the MSP app or on the website. So just if you're an MSP, just open an HMI where you can enter a 17 or 18 digit long number. Not so complicated, right? The next thing is you can generate your own contracts, or you call a service like ours, and the contract is getting generated, is getting signed by VDG, and getting stored in the so-called CCP, a contract pool. Don't worry, it's handled by these so-called ecosystems, which we mentioned before. After this, we're going to inform the OEM backend, hey, a new contract is available. Please inform your customer that there's a contract available for installation. And the next step is the OEM needs to get the consent of the customer to install it. So everything is described in the ISO norm, just the backend connection is open. we developed kind of our way in doing it, and we published it also in the OPNC. So this is not a secret anymore. On our drive, here we used multiple MSPs and multiple CPOs to show that plug-in charge is not like blocking kind of the config selection. It's really open, and you can charge it any CPO. And I can admit, sometimes it didn't work, but then it was an authorization problem, which is a roaming problem. So the MSP didn't have a relationship to the CPO. So why I called the guys, it's not working, and then we figured out, oh, it was an OCPI problem. Damn, this is still the fact. It's still with the RFID card thing. Plug-in charge is not solving this issue of roaming, but we solved the problem of secure installation of a contract in the vehicle. So now if the car is getting parked, you see like the contract is getting handed over to the charging station. The charging station will validate this contract certificate technically. It's just a technical validation of this certificate which is coming from a PKI. So anyone can run a PKI, DigiCert, Entrust, Haptic, whoever, right? This is also driven by SAE and STF. PKIs can be run by everyone. So they need to just pay the price for it. It costs some money. As soon as the certificate is getting validated, it's getting handed over to the CPO backend because they do an OCSP check, like a small cherry on top if the certificate is still valid. And then the EMA ID is getting taken out, 15 characters, which is describing the contract ID. And then this one is getting sent to roaming platforms or via OCPI, again, completely independent on the plug-in charge solution you are using today. So now, enough talking, let's do something haptical. We want to show you now how the user is seeing a config in the car. And we have now in this car already some configs installed. This is a productive vehicle, as you can buy it, and we created this real MSPs. This, you will see it in a second on the camera, many contracts. And then we will sign up, because Hakan is owning now, just for short, for a day, this car. And then you can install with your own MSP, actually, your config into the car, and you will see how fast it is. It's not like don't need to wait a day or so. It's like instant, okay? So now, can we change the camera please to the HMI inside? So now, Michelle is the camera child here for today. Perfect. So now, Michelle, please go to the plug-in charge menu, and can you go a little bit back to with the hand, Michelle? Yeah, better, perfect. A little bit more left. So there's the plug-in charge menu. Oh, sorry, plug-in charge menu, and you see these are the configs which are currently available. Some are installed, 5 can be haptically installed, and some are ready for installation. So like a SIM card, right? You can install them, or you can keep them for now. And now BMW charging is activated, but I said the role play is coming now. Now Hakan is owning this car, and I hand over to you what you do to create your own contract.
Yeah, so Stefan, thank you for the car, first of all.
Shortly.
And thank you for your presentation. So my name is Akane Babil. I'm CTO at ChargeMap. ChargeMap is a French MSP. And today I will be acting like a ChargeMap customer. And I will try to activate plug-in charge in the car. So let's go.
So I will try to moderate a little bit, but now you will see the HMI of the app of ChargeMap. And what Hakan and team did, and hopefully a quick way in opening up a display, like a small feed where you can enter the PCID. Of course, you can add your car. And then here he already wrote it in, but this is the PCID you get from the car. It's a VIN number. Now the contract was generated with our systems, was pushed to the OEM. So, and now we can already, you need to update the screen. Going back to the plug-in charge menu. Now BMW will check our PUT and we'll see there should be, hopefully at the end, a new contract. Ah yeah, CMP. CMP is the provider ID of ChargeMap. For everyone who doesn't know, of course this is kind of e-mobility knowledge, not for the end customer, but here BMW offered a way that the customer can rename the contract. It could be now the company charging, fleet charging, your rental car charging. You just enter your name, that you can remember what was it. You select the contract, it was already installed now, And now, actually, we can head over to to Ming, and we can do the actual charging. So hopefully you saw, how long did it take? 10 seconds for generating a contract and installing it. And now you go out of the car usually. Now Ming is the charging person for this thing. And we can switch to the screen of the laptop, please. And then we can see that this eMite from ChargeMap was used for the authentication authorization. Did it? Perfect. So now the nerd thing is coming out. Where is the eMite? So that is a new challenge for me. Somewhere. And now moving. Okay, next challenge. So until we find out where it is, but now actually what we wanted to show is that within the OCPP logs, the charger was sending the eMite to the backend will do roaming. Of course, we don't do roaming today. It's a showcase for you guys. With the stations over there, it would work. And then the authorization would be approved. The importance for you, if you select a contract, instantly the car will present these other contracts which you just clicked on and will be shown to the charging station. It's not rocket science, right? It's quite simple. Behind there's all these ISO messages and certificates and signing stuff, but technically it's solved. We need to work now on the customer journey. So there's a shout out to all OEMs, also to our friend from Renault and so on. Please offer in the future multi-contract, because it will enable much more use cases for you as an OEM. Like fleets, we know e-mobility is mostly financed by commercial reasons, right? Fleets and so on. If you want to sell a lot of cars on fleets in the fleet sector, offer an open contract selection, because the fleet managers can install their own contracts. They can manage you as a client or as an employee and can check the charging, right? So it will bring you much more sales on the OEM side, which you need, which you want, than featuring your own MSP product. It shouldn't be about discrimination. It should be of offering chances and better services, right? The better service is the business for you. I hope, do you want to plug in again, or? It's okay. So you see, the guys tried in a short minute to fix the station, but we can also show you somewhere else if you like. Any questions for the end?
Thank you. So one part of the process is that we have to install the contract certificate in the vehicle, right? But this is being done by the EV manufacturer. And I'm wondering if what is the mechanism that any mobility operator can have to make their contract certificates available for all the OEM manufacturers, because you may think that for example, one OEM may just agree on installing certificate from a specific mobility operator and not the others, and this may generate like a monopoly on the plug and charge service.
Okay, good point. So we have two topics in your questions. One is, how is it technically possible that every MSP can generate a contract for a car? And here the answer is ISO. The ISO is defining how a contract certificate is getting created from any MO route, is getting signed, like a wrapper around this contract is getting signed by a V2G route, which we have, right? All the cars need to have a V2G route anyhow for the TLS handshake. So that means the OEM will just trust the V2G wrapper because it's coming from a trusted entity like our pool, but the contract certificate inside, I don't know any OEM who is validating the contract inside which is getting installed, because they are trusting the wrapper. Even the ISO is saying the OEM shouldn't check it. Check the wrapper, install the rest. The second topic is a political topic. If an OEM decides to discriminate, okay, I'm not a fan of it, I admit, and some are choosing of our customers to do so, but at the end we have the European Commission with market routes. We have the argumentation of more sales. So you see some OEMs are already going the way of opening up directly from the beginning. But at latest, if the regulation is kicking in and saying, hey guys, the customer needs to have the choice, we will see what the market will do. Of course, it will open up. And most OEMs are ready to open up. They still are in the thinking process. Should I feature my MSP product or should I open up? And here, there's no regulation today in place. There's just market, how to say it, it's called market rules, but it's a voluntary rule. It's a guidance, which we all, I think, in the room understand and would sign it. But of course, there are big groups, ITs and money behind, and they have their decisions. So number one, solved because of ISO. It's an ISO compliant string which is coming from us to the car. Done. If an OEM is trying to feature one, yeah, it's unfortunately the case. Questions?
Hello. I have a question on procedure. If I understand it correctly, the customer, the EV driver, actually have to select one of the contract before he starts the charging manually, right?
Not always. So now one contract is selected, right? You saw it, and for the next charging session, this will be activated.
Okay.
So if you stop, it will show you, hey, this contract is currently selected. If you don't care, you exit, you plug in, and this contract will be reused. If you want to change, you change.
Okay, that I understood. For the customer, as a customer, I might be interested because with different contract, I got different price. So is that any mechanism or possibility to do it automatically change? Because using the contract, I get 50 cents per kilowatt hour. Others might be 80.
I get the question very often. I think just today I had this discussion 4 times. Yes, of course we can start with mechanisms and find out the B2C pricing, right? Like what is the price for this contract at a certain time at this charging station? But is it the right decision to take it cheapest? For the end customer, maybe, if you drive private, but I just mentioned, if you have your company charging contract, you don't care about the price. Your company is paying for it, not you privately. So it's not a wise decision as an OEM to create a mechanism and an algorithm in the car which is detecting the cheapest price for you, if you don't want this. It always needs to be the consent of the customer to choose which contract. If the OEM is providing a nice customer journey saying, with this CPO, I want to have following contract attached, and with this CPO, I want to have this one, it's still the customer need to set it up, it's a good customer journey, and it's still the will of the customer. But I wouldn't do any automatic way. We tried out before, who was it? We found the station for €1.50 close by. Don't go there. €1.50 is quite expensive, right? But if it's company charging, you don't care, right? But if you use a private one, you get problems in your corporate core. You know this, charge point.
For me, it's nice to have an option. Like, yeah, but technically, it's not any challenges, blocking point actually, to get the price from different contracts.
There's no official protocol which is used, but technically, this is an easy thing to solve. It's technically, as a technician, things are possible.
Technically, everything is possible in software, that's correct. But with the current level of standardization of protocols, the car is only giving one contract to the CPO who has access to prices.
Not saying something else. One contract to the, like really, a quick point call, it's always just one contract shown to the charging station. So what can be done is showing the pricing inside the car, right? That you can select before. But that's a different thing.
It's a totally different thing. Yeah. There's no standardization for that.
I was on the right side, you were on the left side. Good. Last questions?
It's not a real question, but regarding your question, you said it's very easy. I think it's not really easy. And it's difficult because it's the price is regarding your plan to charge. I mean, if you charge for 1 kilowatt, if there is a flat fee, you pay something, and if it's for 10 kilowatts, something else. It's regarding also the during of you want to park. So it's difficult to preview the cost of charging before starting charging?
The best pricing what can be provided today is from the MSP, right? You go in the MSP app and you know the pricing. You don't have the information about the volume, how much it will be, but you get the general pricing where you, hopefully, if it's not too complex, understand I will pay roughly this price. If this MSP pricing can be provided now to an HMI of a car or of the app of the OEM, you have the same thing, right? Of course, now with ISO, we know the car needs 40 kilowatt hours. Then the calculation can be done better, right? So the MSP can give more information about, hey, now there's a discount, blah, blah, a blocking fee or whatever. Next level. But first, let's just try to bring the pricing, the B2C pricing of the MSP to the OEM or to whatever app the customer chooses.
Thank you.
If anyone wants to play around, wants to create maybe your own personal content for the car, just come by. We can do this like in the side session. I'm here until Thursday with the car, and then let me know.
Thank you a lot. So honestly, I like the presentation when they end with discussions and open problems. So I think we have a new problem to address within Mobena. Okay, now another session on cybersecurity. So we agreed that cybersecurity is very important and we need to address it. And now we will dive deep into the regulations and the standards shaping this area. So please, Michael Klinger, the floor is yours.
Hello, Michael Klinger from ETAS. I'm in charge of cybersecurity topic for Western Europe. Just start with one question. Who has an Android device, phone, tablet? Raise your hand. Okay. When have you updated your last version? More than 1 month? Less than 1 month? 15 days? 1 week? Okay, just be aware that there is a critical vulnerabilities, several of them, allowing DDoS take on control of your phone, published the 1st of October. Just on introduction. So cybersecurity, it's also related to us as a user. The slides, please. So just to start a very small presentation of who is ETAS, the regulation dedicated to the more OEMs and their tiers. And okay, I don't have any more backup here. The Cyber Resilience Act and some standard and regulation around the world. So ETAS is a subsidiary of Robert Bosch Group. So Bosch Group, it's 4,030 persons around the world, and we are only 3,000. We are located in 12 countries, working with most of all the OEMs and the tiers. And here is what we are talking about. It's not a charging point, it's not a vehicle, it's a very, very big ecosystem. And if we take into account the vehicle at the center, you can see that this vehicle has a lot of interconnection, including that each vehicle is connected to everything. And one of those connections, here it's for the Mobena and VEDECOM, it's of course the charging point station. By the way, for all these links, there are already a lot of attacks. So tomorrow, this vehicle will be connected to the smart city. So imagine what can happen. By the way, in North America, a vehicle is considered under very big IoT. So it's why there is a regulation, the R155, associated to the ISO 2144. Just to be very, to show you the map, all the main countries are applying this regulation, And we will see that even if these countries are not with the UNICEF Wi-Fi 5 like China, they have similar standard. And in a nutshell, who is impacted? Every vehicle that go in our road, including starting in January 25, the two-wheelers. Even if there is only one product with some intelligence, they are impacted by cybersecurity. And what it means that for an OEM, the OEM, as we talked a little this morning about homologation, an OEM has to comply to this regulation without complying on one part on the 7.2 of the regulation, it's governance, it's already addressed this morning, and the 7.3, it's technical. Without that compliance, an OEM is not able to sell any more in Europe any vehicle. So imagine that it's a small challenge for the OEMs and their tiers. And this type of approval, it's only valid for 3 years. And what we are talking about? We are talking about for cybersecurity from design until end of life. Some Belgian study proved that a vehicle life cycle, it's around 40 years. How to maintain in the vehicle domain the vulnerability management system, the cybersecurity state of the art during 40 years is not feasible, but who will pay? And again, two parts, technical part, governance, and of course we are talking also about the production. And that means that the risk analysis has to be maintained during the life cycle, and also that all the stakeholders, all the suppliers are to be managed by the OEMs. But as the OEMs is not able to do everything by themselves, they will request, and they are already requesting, to all the actors contributing to the vehicle, including maybe the application that will be embedded in the infotainment, to be compliant to the ISO SIA 2144. Currently, all the OEMs are sending requests for quotation information to their tiers. If their tiers are not in the path to become certified, they are not selected. There is some discussion to say, even maybe, as I said, the application provider in the infotainment is not still clear. So the ISO 2144, you have on the right part of the screen the synopsis of the ISO, and you will see that there is two big parts, organizational and the technical part. On the organizational point of view, it's, are you able to manage cybersecurity? Have you trained your people? You're aware? Have you trained your people to update your Android device? Just to remind the first question, because here it's also awareness that everybody has to take into account. And on the technical side, are you able to prove to the authority that your architecture is secure? Are you able to prove to the authority that you are able to maintain the cybersecurity level of the product until the end of life? Currently, the main challenge that OEMs and tiers have is how long they will have this contract between OEMs tier. Clearly, 40 years is not acceptable. So the average is between 8 years and 15 years. So it was for the automotive domain. And you will say, okay, I'm not in the automotive domain, I'm not directly linked to that. It's a shame, but now, starting January 25, you will have in Europe to comply to the Cyber Resilience Act. If your product organization is not already under another kind of regulation, you have to comply to the CRI. In other words, you have to comply to the cybersecurity from design until the end of life. What the CRA, just to avoid to read everything, is your product sold in Europe? Is your product managing data? Yes. So you have to comply to the CRA. Is your product processing data? You have to comply. Meaning, charging point station has to comply. So in a nutshell, what is the topic? It's you have to prove to the authority that when the attack will come, and I repeat, when the attack will come, because we know that it will come, you have taken into account the cybersecurity. An important thing, it's the product, but to be able to do that, you have to take into account the life cycle, putting in place also the vulnerability management system. How you will be able to update and to alert the authorities that you have a vulnerability. As I said, here is a little the synoptic. If your product, software, or cloud, or services is dealing with data, personal or not, data, you have to comply to the CRA. If not, you will have some penalties as for the GDPR. And when the authority will come, if you didn't have planned your homework before, as the GDPR, it will be a little tricky. Another one point, interesting also to highlight in Europe, it's less for a product, it's more for the company, IT, it's the NIS2 directive. Why this one? It's to highlight, because here you can see that if your company, your workshop, your offices has more than 50 persons, you have to comply to the NIS2 directive. So what it means that, for example, for we have some OEMs here, what is not clear, it's how each country will implement this European directive locally in the country, because every country will adapt to its own market the directive. But if we take as example Renault or Stellantis, there are some workshops that they have more than 50 persons working in this workshop. Do Stellantis or Renault has to declare as an entity regarding this NIS directive? Imagine the amount of entity of company to declare to the national authority. In France, it will be the ANSI. In Germany, BSI. It's not clear. Nobody knows. So there are a lot of legal persons dealing with the ENISA for the authority. Again, what is very, very important to highlight, as for the UNICR 155 and the ISO 21434, the supply chain has to be managed. You have to manage the cybersecurity of your suppliers. You have to be sure and to ensure that your supplier are able to deal with cybersecurity. It's your role. You are an OEM, you have to manage the cybersecurity of your tiers. You are a charging point operator, you have to manage your supplier. You are a manufacturer of charging station, you have to manage the cybersecurity of your supplier. Just to come back to the 5111.8, to highlight that the Federal Highway Administration published this year that they enforce for next year, so it will be, no, it's already applicable, sorry, the application of the 15.11.8, and also they recommend a certification, even if this administration is aware that there is not enough capacity to certify it. Nevertheless, in the US, it's already mandatory if you want to be part of the vehicle-to-grid ecosystem to comply to the standard 15.11.8. I did not mention China, very complex country. You can see that in total you have more than 11 regulations, more than 100 standards. But to resume, they are taking into account as all the regulation are presenting the cybersecurity at the same level. And if you want to address the Chinese market, you will have some specificity regarding in particular the crypto and what you share there. So be aware about that if you go to China, but you will have to take into account cybersecurity. So in this domain, we call the software-defined vehicle. ETAS is providing all the solution to comply to the cybersecurity that I'm representing, but also to support you to implement the cybersecurity, and for the embedded domain and the embedded part solution, as well for the vehicle itself or for the backend, to support you in the implementation of your solution, including basic software for the embedded part, our solution coming back to the cybersecurity, our security module, it's already deployed in more than 100 million of vehicles, etc. And from a consulting point of view, here it's the security portfolio. You see that we have an extensive portfolio regarding cybersecurity, as well for engineering, for consulting, addressing all the regulation, as well for the technical part or governance part, vulnerability management system, security operations center, in order to support you to comply to these regulations. Thank you. Have you some question?
We have time for one question. Okay.
Okay.
Thank you a lot for the nice presentation. So again, to ISO 15118, which we repeat and repeat, one of the most important aspects and standards within e-mobility. And now I call Derek Grossman, the Senior Manager of Board Electronics for Charging Infrastructure, which will take us on the journey from standardization to implementation. The floor is yours.
All right, so thanks for having me. As mentioned this morning, I'm the guy behind the scenes. So this is all about ISO 15118 and a little deep dive into what we're doing in standardization, what to expect in the next years. So, so let's start with a general overview. How is the ISO standardization organized? Actually, it's a joint working group between ISO and IEC, and I'm the convener of this group together with Peter Thompson from ChargePoint. And inside the committee, we are organized in different project teams, and the project teams then are associated basically to the ISO OC layer on the technical level. So that means on one hand side, of course, we had a PT1 that was defining the use cases. So what do we want to address with all the specifications that we are creating? And then I think most known part is then the PT2 that is dealing with the software layers. So that is what's always meant if we're talking about ISO-2 or -20 document. This is exactly the group that is specifying these documents. And then we have also heard about, this physical layer. We have PLC, we have Wi-Fi. Now for MCS, we have 10-based T1S. So that's all the hardware physical layer stuff, though that's done in PT4. And then we have also the conformance test, also something that we heard today, that's handled then in PT6. So this is how we run the group, and we have heard about ISO-2, -20. So what's exactly inside these documents? What is part of the documents, and therefore, I always consider this a first generation that we started with the -2 document, and that was focusing of AC and DC charging. So one standard that's able to cover both AC and DC charging. So the monitor went off. Can we get that on, please? Otherwise, I have to go here. Okay, then we introduced things like smart charging, where we have power schedules or sales tariffs included. And obviously, already at this time, we considered the security aspect with TLS. So, I mean, the standard was published in 2014, so that's 10 years ago. And when we started, it's working now, yeah, thanks. And when we started, discussing it, that was in 2008, 2009. So that means, we had to think 15 years ahead what is required then, and how do we, factor that in a standard that is holding true for so long time, and that we can, that we had to foresee in things like, the security aspects coming up. So that's already factored in at this point in time. And the safety aspect regarding the charging process, we tried to keep that out of the software part. So that's completely handled within the IEC 851 part. And last not least, already at this time, we envisioned that in parallel to the charging session, there might be the need for value-added services, so an additional channel besides the charging channel for additional information to be exchanged. One topic where that is used, one area where that is used today is in the bus industry. They use it for pre-charging of the vehicles in the depots. So once the vehicles are in the depot overnight, they can precondition the interior with the energy out of the grid, so they don't have to, cool or heat the vehicle, or start cooling or heating the vehicle when it's on the road. So they just have to maintain the temperature when it's on the road, but they don't have to take the full energy to the initial cooling or heating directly from the battery. They can take it from the grid. Then, obviously, over the time, the ideas evolved, and that's why we then started creating the second generation, what's meanwhile called -20. Yeah, so topics came up that we already heard today with the bidirectional charging. How can we accomplish this? Wireless power transfer, so we have inductive charging systems, and then also automatic connecting devices, which could be on one side pantographs that we heard earlier this morning, or even for MCS systems, if the cable and the cord gets more heavier, maybe you need some automated devices to really plug in, because the cord is just too heavy to be carried. And additionally, we enhanced the control modes with a dynamic mode, and as said, we also, if we do wireless power transfer, we have no physical connection anymore to the vehicle. Obviously, we then also need a wireless communication to do the communication part, and therefore we selected IEEE 802.11n. And in the second step, we then made the TLS part mandatory for all cases. So, as said, first generation, second generation, I don't read the whole slide here because, but you can take a closer look afterwards, but this is basically just showing you then which document belonged to first generation and second generation. There are some new additions for some of the documents where we made some enhancements based on industry feedback over the years. And we also, as I said, had the conformance test documents for the standards in there. So again, another view what's incorporated in the documents and how the individual layers and the ISO OSI model are reflected, and how the conformance test documents also map then to the software requirements in general. Okay, so that's the document and how the document structure and what is contained in which document. We have heard so much about, the charging process and lots of the PKI stuff, but how does the actual charging process look like? What are the steps? And if we also heard today already, we cannot only look at the vehicle and the charger, but we also have to look at the back end as well to see the whole chain, and therefore the ISO protocol only handles the communication between the vehicle and the charger, and then from the charger to the back end, it's OCPP, and that's a complete new connection then, and the charger is able to transfer the data from one protocol to the other and vice versa. And how is that chain run through a whole charging process? So that will be the next slides. I run through maybe a little too quick, but you can read that afterwards. So once you plug in, that's detected by the charger, obviously, and then information is then sent with a transaction start to the back-end system. Then the identification starts. That's exactly the part where we're talking about either RFID or plug and charge with certificate-based charging. So the way to identify you and to get the authorization then by the back end, and therefore whether it's an RFID card or a plug and charge PKI certificate doesn't matter, because you have to get the authorization from the back end somehow. So then we have to exchange the charging parameters. So what's the state of charge? What's the energy amount requested? Maybe the departure time. Yeah. So these charge parameters are then transferred via the charger to the back end, and the back end then can offer various charge schedules with energy amount over time. Maybe it will also add price information over time, things like that. There can be several schedules which offer different possibilities being offered to the vehicle, and then it's the vehicle to select one of these profiles, and that's basically where the contract is then made between the vehicle and the infrastructure side, because this is then the profile that has been selected and that has been agreed upon from both sides. And now we are finally able to get the energy into the vehicle, and the actual charging process and the energy transfer starts. And during that phase, the meter values or the charging, the energy amount is reported to the back end continuously. So that's the whole charging process, and you have seen the plug and charge part is only one message, so to say, in the whole process. Definitely important, yeah, but it's only one piece of the whole charging sequence. Okay, so the question is, where are we today, and what's next? So, as I said, with the -2 document, it's out there since 2014, and currently we're working on a second edition. Over the years, we gathered some market feedback. Obviously, some of the requirements were maybe unclear. Try to solve that. Another aspect is that we want to better align with the overall IEC 61851 standard, so that they really align better from the standard side. Document currently is in a pre-FDIS state that has timed out, so we have to redo the whole process. Unfortunate on this side, but that's based on some ISO regulatory stuff. So technically, document is there. We try to rerun it through another review cycle, and then probably, mid of next year, we'll have the second edition out then. -20, it's out there since 22, so 2 years. It's out there. Currently, here we're working on what we call an amendment. So that's the possibility to add additional topics to the document without redoing the complete document. What's in there? One aspect is AC bidirectional DER support. So that means at the beginning, when we designed the document, we had lots of input regarding DC bidirectional. AC was a little low, I would say. Secondly, the way we designed, or the system we anticipated at that time, was in a way that the idea was that the wall box or the charger contains all the grid code information, and the vehicle doesn't know anything about the grid code, just to keep the vehicle more simple, and then have the wall box handling all that grid code topics, and then just transfer that in the voltage and current set points, basically, for the charger or for the converter inside the vehicle. All the grid codes handled inside the chargers. Having that out, basically got the feedback, especially from US market, that they're not able to certify such a split approach. They always want to have the information of the grid codes where the inverter is. So that's why we, based on this, we will transfer now in a dedicated service. We are able to transfer all the grid code information to the vehicle, and then the inverter inside the vehicle obviously has to handle all the grid code information and convert that into the appropriate voltage current set points internally. First thing. Second thing, we addressed the topic of megawatt charging systems. So also heard that, for example, for mining, marina or aviation industry, big topic. On one hand side, we looked at the charging sequence that can remain the same. What we had to do is to change the physical layer. So we're not using PLC anymore. We switched to 10-base T1S on the physical layer for megawatt charging systems. And we had one issue with a certificate profile that's also fixed within the amendment. We had other stuff that we were planning to introduce based also on timeout information from ISO side. We had to finish the document. We basically skipped those things. We will introduce them either in a second amendment or we will do a second edition then of the standard, but the FDIS has been submitted last week, and now it's in FDIS ballot, and then I hope beginning of next year the amendment will be out for public. So as I said, for megawatt charging, we had two options, differential PLC or 10-base T1S. So there has been a voting on IEC side, and they have selected the 10-base T1S, so that's why we introduced, or we will continue with then the -10 document and the -6 document. We just we'll run in a timeout and then it's not there anymore. Again here, document currently in FDIS stage. FDIS has been submitted, so waiting for review here, and then hopefully also beginning of next year we will have then the document published. So last parts here, looking at the conformance test part, -4, which is the conformance test for the -2 document. Edition 1 has been published in 2018. So currently for the next edition, we have submitted the DIS part, so it's under this review. Obviously, we made some general corrections, added a couple of test cases. So overall, it's around about updated more around about 500 of the test cases. So that's quite a number in there. And then for the -20 document, there are also conformance test cases we are working on. As you have seen, -20 contains a lot of use cases and charging scenarios, and the question at the beginning was, okay, we will not be able to cover all of them in one single step. We have to take it one by one, and based on industry feedback and importance for the industry, at that point in time, DC was the most important thing to be covered, and therefore we basically split the test cases in, let's say, common requirements that are common among all the different use cases, and then the individual charging parts, and therefore we started with the common part and the DC part, and you can see the timeline as well here for both documents. So we have a lot of documents out there, and as I said, the feedback from the market and people implementing that, really important to improve the standard, and as you have seen, we are able to do that, and we continuously will do that. But how do we collect the information from the industry? So there is no ISO way to do it, therefore we had to create something on our own, and therefore we are happy that ELAT is able to host a GitLab server here, so everyone here, don't have to be an ISO member, you don't have to be an ELAT member, everyone industry-wide, worldwide can participate. Just register here, it's a one-time registration that we have your name and your email in there, and then you can post questions to the standards into the different user groups, and they will be then answered by the ISO experts. We have regular meetings where we go through the open topics in the user group. We will answer them, so you have you get feedback how to implement the things you are missing, so to say. If these are things we see that are not properly defined inside the documents, we will basically mark them internally and take them for the next update of the document, so that over time we will really make the documents more solid and precise in the end. So that's from ISO side, and doing that in 20 minutes, quite a challenge. But as I said, ISO, okay, we are great, and it's a great standard, but okay, we're not the only one. Yeah, though there's more out there. As I said, there's the DIN spec for DC charging only. We have the IEC part for CP and PP handling. We have SAE, for example, SAE J3105 for upcharge pantograph charging. Other SAE standards out there. We have J3400 for NACS. So there's a whole other standards out there, yeah, that you have to deal with. And that's exactly now we have, as my title of the presentation is, yeah, from standardization. I mean, that's understood now, but how do you turn that into implementation, and what does it really takes for that? And that brings me to the vector portfolio that basically covers all the products from the vehicle side over the charger to the back-end side. We're able to support and to take away parts of, or lots of these requirements that are covered inside the standard are covered by products from us that will then enable you to focus really on your implementation of application or vehicle integration and charger integration level, whether it be the embedded software for the vehicle side, whether it be the charge controllers like the VSAC single on the charger side, or the test systems Fanel talked earlier about, or vCharm as a charging backend. If you want to see more on that, please come see me after the presentation. I'll be around until Thursday. Happy to talk about that in more detail. And if there are any more questions for today, I'm happy to take them now, or yeah, come see me later. I'll be around. Thanks very much.
I invite you to ask direct after during the networking session, because we're a little bit out of time. Thank you a lot. Very
I'll
nice
be around.
presentation. Yeah.
Thank you.
Just to give you some a lot of credit, because it's really hard to present ISO 15118 and what's happening and what's the future in less than 20 minutes. So thank you a lot. And now we will move to a very hot topic a lot of people are talking about and a lot are interested about, which is vehicle to grid. And we are fortunate to have with us Didier Duret, expert from Renault, already presented during the roundtable, and I'm happy that you can give us more insight on vehicle to grid. The floor is yours.
Okay, that's it. So the question is lesson learned and future outlook from one of the first paper about V2GIC. Okay, the first lesson learned, if we are talking about V2GIC, it takes time. The first introduction we have in terms of V2G was more than 10 years ago. It was in fact led by Nissan. Nissan has introduced the Leaf in Japan. Japan was facing a major crisis that was Fukushima. And for the first time, they defined a solution that was called Leaf to Home. They were able to supply home during a blackout caused by the Fukushima event. It was the first time we did a clear link between the electric vehicle and the home, and we discovered that we have the same energy and that we are able to do more. So there was a lot of discussion about this technology, and this technology started to be, let's say, strategic, and we decided to go further. Nissan continued for the V2G at the DC side, and Renault decided to go and to have a look on the AC side, just because synergy, we don't work on the same topics. And the other side, if you remind, Renault at this time was only delivering AC charger on his car. So we tried to implement in terms of advanced engineering, and in terms of advanced engineering, we were looking how to do that. So we decide, as I explained this morning, the job allocation between the wall box and the car. We discuss about the protocol to support all the function and the grid code, and it was ISO 15118, what is now -20. And we do all the tests to demonstrate that we were able to do, at lab level, we were able to do all the services and follow the grid code. According to that, we go one step further. It was the third step. We built 15 beautiful Zoe Blue that have a bidirectional onboard charger embedded, that have the first draft of ISO 15118, and we put this car everywhere, let's say in Europe, if you have Utrecht, Belle-Île, and Porto Santo, just to show the technology to stakeholders and to show where we are, what is the state of the art, and get their feedback about what could be the leading for implementation. According to that, we have a major decision, is to go for mass market, and to go for smart market is the car that is there. So, as I explained this morning, we decided to go for mass market, not on limited edition, no on a specific product. We decided to go on mass market on our iconic car, that is a Renault 5. You are all in Europe, I believe you know the blue one, for some of you. And we decided to introduce on the yellow one, or the green one that you have here. And we decided to implement the technology for all the car, all the Renault 5 have a bidirectional onboard charger. What we wanted is not to go with a car and say we are V2G ready. There is no value for customer to be V2G ready if there is no V2G services. So we decided to introduce all the enablers, all the technobricks to be able to provide V2G services at the launch of the Renault 5. Of course, the car, I won't discuss more about it. We have to build also the wall box. We did it with a partner that is Ioteka, and the wall box is assembled in France by Lacroix. And it's a wall box dedicated for V2G AC. And we go one step further. We decided that the most affordable services for customer is energy trading. I mean, it's very simple. We charge in the car when the energy is low cost on the market, and we discharge when the electricity is expensive. And we save money just by trading in between. To do that at home level, we need to be the energy supplier, because there is only the energy supplier of the home that is able to buy and sell energy. So we will provide an energy contract for home. You will have to change. That is based on what is most competitive contract for that. And the final enabler to provide the full services is to have all this function integrated in your apps to be able to follow what happened and decide whatever you want in terms of charging. How does it run? First, I explained this morning when we designed this service, considering that an EV is a mobility object and it's always mobility first. So we ask the customer to define what will be their needs in terms of mobility and where he will accept to have V2G session. It's based on a principle. The first principle is a schedule. You will define which time, if you plug, you agree to start a V2G session. For an example, if I plug between 6 p.m. to 8 p.m. in the morning, that means my car won't move, you can do V2G session. If I plug not in this time, I want normal charging, and I don't want to discuss about that. The second thing, as we will discharge the car, we will discuss with the customer what is his minimum level of energy or minimum range he needs, whatever the time. And if he plugs that the car is below this level, we will start charging to this level. And we will never go below, so it's a safety range. It will always be secure to obtain. And the final point for the customer needs, at which time you want to leave, and what will be your target in terms of state of charge, for example, 8 o'clock, 80% of charge. Okay? So that's it. He fill it once, and as soon as he has defined what are his needs, we will first comply with it. These needs are sent to the car by our backend, or clearly set inside the car itself, transmitted to the wall box and to the operator through ISO 15118-20, from the wall box to the backend using OCPP, And with that, our aggregator, that is the mobility house, TMH, is able to monitor the services, but he has to monitor the charge services and the energy services. But once again, the charge is priority to energy services. And that's the way it works. Where we are today. So I take just the last year because it's the most interesting for us. It started by, let's say, a little step for energy. It's the first kilowatt hour that we really implemented in a real home. This is a Linky. It's a French smart meter. So it was a single step, a small step for energy, but a big step for V2G because it was the first kilowatt hour we inject inside the network, the French network. We decided that we have to work about robustness of our solution. And so we decided two things. We decided to install many wallbox at the techno center that are reversible wallbox to be able to do multiple V2G sessions as soon as we want. And we decided with the help of Enedis to introduce real-world customer that we provide them with a wallbox that was not completely certified. So that's why we need the assistance of Enedis to agree about that. And with cars that were not also completely finalized, and to start the services and to see in real world all the things we do not expect to encounter, okay, and to have a more robust solution. According to that, we were able to fix the design of the car. That means that the hardware of the car is freeze, and we are sure that it will comply with all the grid code and all the requirements, because the car, let's say, is always the object the most difficult to validate and to modify it. Okay. Few months later, we did exactly the same with the wallbox. Okay. And in September, we achieved to obtain the first certification. I explained this morning that it was a big challenge, so we get the first one for France, and we are ongoing for Germany and for UK. Okay. And we are under the finalization of our offer. We will go for the what we call go for market for the wallbox before November, and the idea is to have the first customers that will have the Renault 5 delivered beginning of November to be able to subscribe and activate the V2G as soon as they get their car. When we talk about the state of the art, I was mainly explaining about the grid code. Today it was probably one of the most difficult things we have to comply. I explained already why. There is, of course, a European regulation that says that you must comply with grid code to access to electricity market or to electricity grid. That, in fact, this European is not harmonized, and each country has defined its own grid code that you have to comply with. That means that for this version of V2G, we have to certify both car and wallbox at the same time. It's a complete certification for the two products. And we have to repeat countries by countries to get the certification to go in France, Germany, and so on. Okay? And if you are looking the amounts of requirements you have, each country has defined its own variation. You have more than 1,000 pages of requirements to adapt to a product and make sure it's compliant with, which takes time and it's not very easy. And sorry, I will go back. And one thing also I explained this morning, our solution is not completely interoperable, not due to the fact that it don't want it to be, it's just because the standard was not at a level advanced enough in terms of level to do so. So we did our own interpretation and we did our own implementation based on the standards as they were at the beginning. And the only specification that was finalized is ISO 15118 and 8-20. That's why the car is interoperable for this protocol. What is moving? The next step. There is a change in the grid code that is planned by European Union. It's under discussion and will be officialized beginning of next year. We call it Request for Generator 2024. And due to this new regulation, we know that our actual architecture won't comply. There is more stringent requirements that our architecture cannot fulfill, so we will have to change. As explained, the grid code must be transmitted from the wallbox to the car due to the fact that the reaction time requested by the network cannot be fulfilled if you depend on the ISO 15118 communication. So it will be rework, it's under consideration. And what we hope also with this new regulation is the grid code. It's a challenge, it's a dream. It's a grid code to be harmonized across all Europe, because there is we had to rework due to the fact that the requirements are new. We hope that the rework may help to have one harmonized standard for all. Just to explain, there is many opportunity, because it's clearly what is requested in RFJ 24 about that, to have harmonized requirements and to have an independent certification between car and vehicle. That is key for interoperability. So it's the scope. We have to define how to do it, and we have to update all the normalization of the standard to be able to do that. The one for the wallbox, the one for the car, the one for the certification, and the one for the communication. And that's it. So that's my first dream, that we succeed to have that. My second dream is now that we have succeeded, let's say, to have the first V2G, but limited to one services for the moment, mainly in France, but coming very soon in Germany, UK. And with one location that is home, but we want to go far away. I call it multiply. So of course we want to multiply the source of revenues, new services that can offer the technology. We want to multiply the assets we will be able to monitor wallbox other than us, cars other than us, and whatever, and even why not home. And if I go to be able to do in every ecosystem, at home, at work, on public station, and so on, everywhere in Europe, and why not in the world. That's all about me, and I'm welcome if you have some question about this implementation.
We have time for 1 or 2 questions.
I save time.
Just one question. If the user have 2 Renault 5,
yes,
would it be possible to use one contract with the 2 cars, or to have 2 contracts?
If you have, it will be possible to have the 2 contracts in the one contract for each car. In fact, it's only one contract because it's a wallbox that is monitored. And the wallbox will detect that the car is V2G enabled and will do it. Whatever the car is plugged to the wallbox, in fact. Okay, so it's the same contract.
And if a user has 2 homes?
He will need to have 2 wallbox with the... but it's a very rich way. We love it. If you have 2 cars to run a 5, it's a good guy. If you have 2 wallbox, no problem about that. But he has two energy contracts, so it's no problem. It's like it's completely separated.
You just raise your hand. I have 2 questions. The first one is if I install one of these chargers at my place, my home, do I have to modify the electric circuits in my the installation of my home to be able to inject energy? Is that part of the contract you are offering?
Yes, when we do the installation of the wallbox, there is an administrative task to be done because you are installing a generator. It's not specific to V2G, it's like if you are installing a solar inverter. So we have to inform the DSO Enedis that you want to install V2G cars. We want to explain we have to demonstrate that the installation is safety compliant and grid code compliant, and you get the approval to start the injection. So there is no major change in your installation. It's exactly the same installation that if you install a charge, only a charger, not a wearable one. You would have the same layout in terms of safety device and so on, but you have this administrative task to be done like if you were a solar inverter. So it's not something new for vehicle, but it's clearly not new for grid operator, DSO, and so on.
And you can choose as user to either power your house or power or sell the energy to the power grid, or is this only for the power grid to inject energy to the power grid?
For the moment, the only service we are offering is energy trading, so that means that the customer cannot decide what will do the car. It's led by the aggregator to get revenue from the market.
Okay, and
so we are studying other kind of services where the customer may decide, but it's not what we are offering today.
And the second question is about the revenue you get from this trading. When we use the car for V2G and the converter is inside the car, it means you are using the power electronics and the battery, not only for traction, but to reinject energy. This will maybe reduce the life expectancy of the power electronics. And does this revenue from the energy that compensate the reduce of the lifetime of your car?
Yes, they do. Whether we don't know. As I explained this morning, you can do V2G as there is absolutely no consequence for the warranty of the car. And so the traction unit and the battery are warranty, I'm not sure, it's normally 8 years and 150 kilometers, and there is no change in warranty. This warranty is not affected by the fact that you are doing V2G. That means that when we design the car, we take into account these services, and it's been for all the validation, testing, and reliability compliance, we included the V2G as part of the vehicle life cycle.
Okay, thank you, Didier.
You're welcome.
I see that it's a common interest to see the revenue or the gain of trading energy, or maybe leveraging dynamic tariff. So leveraging dynamic tariff is the title for the new topic. I call Sasan Minion from WhatsApp, who will be actually presenting Things in Action, a demo on dynamic tariff, and Matthew Felsi from Schneider Electric, who will be supporting the demo.
I'm not sure that I can put it. Okay. Thank you, everybody. Thank you to be here. So in this event, we will talk about the dynamic tariff for smart charging in electric vehicles and how we can earn money in this situation. For the first step, so we will have some explanation about the context, because there are some issues, real issues for some actors in the ecosystem, but we will show you that there are a lot of opportunity for them, for other actors also, and we will show you what we can propose you, a solution, and regarding Mobena, we work with the other actors in this ecosystem. So maybe the next slide. In the end of this event, we will show you the demo with the car, with the charge point, and with the dynamic tariff. It's a reality that we can show you today. So regarding myself, maybe the next slide. So I'm from WhatsApp. It's a startup in electromobility since 3 years. We provide some solution for CPOs as a white label for MSP, covering 32 countries in Europe and more than 4,100,000 charge points. And okay, thank you. Okay, so, and currently we are working on smart charging, and the smart charging, one of the subject in the smart charging is the dynamic tariff. So I'll let you just explain.
Hello, my name is Mathieu Falsi. I am an offer architect at Schneider Electric, and I'm working on the e-mobility and prosumer offer. E-mobility is self-standing, and prosumer refers to users that tends to be an electricity producer on top of this electrical consumptions, right? So, and today I'm pleased to help Sasan to bridge the world between the building management system and the e-mobility charging infrastructure.
I show you some slides here. It's the situation of the one day in the this summer, but it's not the only day. So we can see in the left side that the production of energy in this case in France, but it's really the same in the other countries. What is interesting is during the afternoon something happened. And what is exactly is renewable energy is coming in production. And as you see, so they should stop the nuclear center. So it's a yellow side. And because the renewable energy like photovoltaics is coming in production during afternoon, and the power company, they don't know how to manage it, so they should stop the production. So maybe they can store it, for example, in the battery or the things like that. And in fact, their price of energy is impacted regarding this situation. I explain you because it's something is tariff, spot tariff for energy providers. It can be spot tariff. It's every quarter of an hour it can change, and we know it 24 hours before. And as you see this situation, because of full of energy that we have during the afternoon, the tariff is negative. That means they pay you to consume energy. Or if you product energy, you have to pay for that. It's something very strange situation. So, and it's the real problem issue for the power company. What we can do, so it's something that we worked on it about this situation in Mobena teams, to try to use charging period during the time where the energy is full, and reduce the consumption when the price is high. So as you see, the price, the availability of energy, and with smart charging, we really can have the good add value on this situation. So in this step, I can show you that because the smart charging is already defined, so we can use the peak, or we can use the other situation for smart charging, and to use the what we call it the time to use of energy. What is that we can show you, so that for this demonstration, so that we worked on it together?
Yeah, so just to explain how it works. So basically what you can see in this simplified view is the overall setup that we have implemented for the demo. So on the left-hand side, you can see the EV or e-mobility vertical, from the charging station to the CPO system that WhatsUp implements. On the right-hand side, you can see the building management system, which starts from the power meters, the things that are connected on the field to monitor the energy, which were monitored by our edge management system, our power monitoring experts, which then provide data to our cloud backend system for exchanging with our partners. So this is really 2 verticals, 3 layers, from the things to the cloud.
Okay.
And maybe just maybe one more thing, if you can come back to
Sure.
this slide. Yeah. As Sasan just explained, so in the tariff optimization, you have two folds. You have the time of use, which is basically shifting loads in time, and you have the demand charge, which is managing the power so that you cannot exceed the power demand. On the left-hand side, WhatsApp will get the tariff data from the aggregators, sorry. And on the right-hand side, on the demand charge, this is where you need the data from the building to get to know how much the building consumes at this period of time. Because if you shift loads in a period where the building already consumes a lot, you will get into a demand charge extra cost, right? This is why you need those data from the building.
Okay, thank you. So for today's demo, so we have a car, we have a very nice car, we have a charge point, so very nice charge point, and we have the WhatsApp solution with flexi level. This here. Okay, so let's go for demo. So what I can show you, it's switching to my PC, please. Okay, so the demos, as you see, we have a charge point. So this charge point of here, it's a three-phase charge point. So normally it can provide until 24 kilowatts for power. And we need also to define the price. So this is the price which is, for example, coming from the power companies or spot tariff. And it's, as you see, every quarter of hour it changes. So the aim is to plan the charge point regarding this tariff. When the tariff is high, reduce the capacity. And when the tariff is low, improve the capacity of the charging. Here, as you see, the system defined regarding these tariffs, the profile of charge. And as you see, for example, this period, for sure that is the best price. So we will add this profile to the charge point. And where is very expensive, we can until stop the charging and to staying for the next period to charge the car. So price, plan of charge, and in fact, so as you see here, for example, we did this charging with this installation, and the charge is going on and until the aims, but sometimes the capacity was stopped. So there are some flat for this period. Even sometimes it was stopped charging because of tarification. And the next step, we can continue to charging. And we think we can really improve the cost of charging, and so have to until even 70% of charging will be reduced. So it's very interesting situation for the fleet manager and also for energy companies to have this facility to flexibility to manage their powers. For me, that's it. So yeah. So if you have any question, I can.
I might maybe add one comment on that.
For sure.
So clearly there is added value, okay, by bridging the building with the e-mobility. But of course there are also challenges. And this morning we have been emphasizing on the interoperability challenge and all the protocol and data which are behind. And clearly in this demo, what we can say is that today we are clearly missing some protocol and data semantic normalization on the building sector, right? Because we have seen that on the e-mobility sector, I think we can leverage on those modern standards like OCPP, ISO 15118, which provides data on top of protocols. which is not at all the case in the building sector, where we miss semantic, we miss contextualization of data, because in this demo, for instance, we are bringing like 20 sensors from our labs. But now when it comes to know, okay, what is the meaning of each sensor, what is the data, is it power, is it active power, is it demand, is it energy index? So this is everything that we need to build in order to really provide an interop guarantee. And today we have been building this demo as a turnkey solution, which is not at all viable at scale, right?
Okay, in fact, also in that, I call for the partnership because as we show you, the demo is really a successful action, and we are looking for the other partners to join us for pilot sites if you have any project regarding these kind of things. We also have the government grants that can help us until 50% of the cost of project. If you are interested about this situation, this kind of project or pilot, please contact me. Thank you.
So how far along are you with the demo? Do you have real life data? Can you say how much you can save in comparison to a normal operation without this optimization part? Do you have some data already there?
So for that, even for V2G, we had some tests, and it's really depend on the situation. I mean, if you agree that your fleet is it can stay under, plugged, and if you don't have any go out for stopping the charge, it can go until 70% to improve the tariff.
You think you can save 70%?
Yeah,
of the cost?
Yeah, as you see, we can even earn money if the time is, yeah. So if there is no contract.
So with V2G,
no,
so it's always out.
Even I don't say about V2G. For sure, V2G is very interesting also, but as you see, there is some period that the tariff is negative.
Yeah, I mean, that's understood. I mean, but on a long run, because we're running the same system already. We have something like dynamic tariffs in our system, and our savings are like 20%. So that's why I'm really surprised when you say 70. So I don't know what you're doing there.
No, I say until 70%. I know that you had some experience in Germany. I think that you run your system, but if there is no, contract for stopping charge, we can choose the best period, and the best period can be really interesting.
But at the end, everything is bind to the tariff structure. So you don't have one answer to this question. Everything depends on your tariff structure. In some country, you are stuck very, 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 very soon. In some other countries or DSO, you might look at larger savings.
No, we're taking it also from the stock market. So.
Yeah, but still, it depends if your DSO provides you with this tariff flexibility as well.
And even in France, there is some rules that is very specific in France that we call it autoconsommation collective, the autoconsommation, how you can translate it, the collective autoconception. And if, for example, you run it in this situation, it's really full of benefit for you. And because in France, you can sell your energy to the people, to the private.
Thank you for the presentation.
Sure.
One question. As far as I understood, you're using intraday market. Do you also consider using other markets like day ahead or even over the counter? Do you think about using predictive optimization, such as to incorporate some kind of weather forecast, load forecast, and play with the different markets?
For sure, there is the opportunity for all these devices that can be used in private, but also in the for the companies. They already had the solution for this kind of devices. That means, for example, for the heat at home, they have some flexibility, and you can earn money on it. But for charge point, there is not really in France. I know that in the north countries in Europe, they have already run this kind of offers, but in France, it's not yet run.
Thank you.
Any question?
Hi, this is Julia Hildermeyer from Regulatory Assistance Project. We are a think tank working on energy transition, and I lead our e-mobility work. I wanted to ask exactly on your last point. Do you have any experience of how smart charging works in other countries, from deploying your service or studying where you could do that in the future?
We are working on it, so we have just planned to produce a document on it in Mobena to have collect some experience in the other countries. For example, I know that in Germany they had some pilots. In North America, countries in Europe, they have a real offers. Market is really there. And yeah, so we will produce some study about that. Okay, I think there's no other. Okay.
Thank you, Cesar.
Thank you. Thank you.
Thank you. So I repeat the call of Cesar for partnership on this very interesting topic. If you would like to join hands and work on dynamic tariff, please contact Cesar or contact Mobena for more information. Now, our last but definitely not least, we'll continue focusing on the energy sector. We have a round table of very interesting speakers, which will talk about the energy sector in the era of massive deployment of electric vehicles. I call Karima Bouker, which is our moderator. Karima is a holder of PhD in math and senior consultant in electric mobility within the French DSO Enedis. Karima, the floor is yours.
Good afternoon, everyone. I'm going to moderate this round table, which is about mass deployment of EVs and how to tackle their accommodation on the grid, low voltage and high voltage ones. I'm going to, where is our panelist? Pictures? Is there? I'm going to call Julia Heidermeyer, who is a senior associate and program lead for transportation for EU programs. Julia joined the RAPS Europe team as an electric mobility and transport expert to explore the benefits and integration of electrified transport in a smarter and decarbonized power market. Welcome, Julia. I'm going to call Glenn from Charing. Glenn? Yeah, hi, Glenn. So Glenn is head of public affairs at EU level in Brussels, and you have been working for 17 years in public affairs and business development, even in Brazil and EU. I'm going to call, I think, from Total Energies, Louis. Louis de Lepinot is in charge of innovation in the subsidiary of charging services from Total Energies, and Louis is managing an engineering and new services development team. You have been working also for more than 10 years in electric mobility area sector. Thank you. I'm going to call Nicolas Leclerc from Stellantis. Yeah, Nicolas is the head of strategy and technology partnership in Stellantis. And last not least, of course, Université Gustave Eiffel, represented by Jill Ney. Hi, Jill Ney. Is a directeur de recherche, I think so. In English, it is senior research scientist, and you're dealing with nonlinear control of power systems applied to electric grids, power electronics, large-scale renewable, ancillary services, and that includes also inertia and fast frequency support, and on the top of that, EV integration, obviously. I'm going to sit with you guys, because it will last 50 minutes, and then we will leave 10 minutes to the audience for the debate. I might need a microphone here. Okay, is this working? All right. So, by curiosity, Louis, we have just one question, which has nothing to do with the discussion. You are a CPO within such a big group like Total. How do you feel this organization? Is it comfortable, or is it the opposite?
I think it's a chance to have everything at home, I would say, and to have all the internal forces and expertise. But I think that we also encounter the same limitations since we don't speak the same language, I would say. As a CPO, when I first time knocked on the door on our internal energy supplier, they were laughing at us. What is your peak load? 1 megawatt? Oh, 2 megawatts? So it was 2 years ago. It's nothing for them. So I think also internally we really have to educate ourselves to just that they understand my challenges, my job, basically, my customers, and I also need to understand their challenges, you know, their industry, their priorities, and then we have to find a path between our two ecosystems. And I think basically that's what Mobena does, and it's a good thing.
Okay, great. Nice to know. Shall we move to regulation, maybe, and to some challenges? Julia, do you see any challenges in the future for mass deployment of EVs and their accommodation, of course, and what do you suggest?
Thank you. So first of all, I'll take a minute to introduce Regulatory Assistance Project, because not everyone may know us. We are, let's say, a small group of experts working on policy experts, I should say, energy policy experts, working on the clean energy transition. We're a global group working in the US, China, India, and Europe, and I lead our electrification of transport program in Europe. So when I talk about EVs, I always look at them as both an asset of mobility, but of course also a resource for the power system. So it's really all about the integration of EVs into the grid. And yes, there are a few bottlenecks that we need to solve before we get to mass deployment, that's obvious. But first of all, I'm also here, I think, to sort of help us zoom out to get the bigger policy picture of things. It's worthwhile asking the question, why is EV grid integration and optimizing EV grid integration actually so important? Well, basically, if we roll out EVs on a mass scale, and I think, you know, we're getting there with passenger cars, there's a lot of movement in the electric truck space, so it's really a very interesting point in time looking at the market. So what that means is that there's more and more electricity demand that is being put from an additional sector to our grids, to our power system, which needs to cope, which is used to plan much more in advance on a much more, let's say, predictable way, and is suddenly facing a sector which is electrifying extremely dynamically. And actually it's not the only one. We're seeing the same development in heating, with all those heat pumps connected. So as electrification moves forward really quickly, we absolutely need to do that in the most beneficial and optimized way to save cost for the user, for any EV user, for fleet users, but also actually for any electricity users, even those that don't care for EVs, because they'll also pay those costs via their electricity bills, right? So we need to save costs for the users. We also need to save costs for the grid, because, you know, that's just an obvious thing to do and use them better. And we need to save cost for the environment, because as we use flexibility, for example, in EVs, all those small-scale assets, we use capacity much better, and we help bringing renewables into the system. So that's like the sort of win-win-win situation that we see with smart charging or optimized charging being enabled. And that's why I'm really grateful for the previous discussion, which I think is absolutely key. If we do not do smart charging, if we don't optimize EV use for the grid, we're simply risking to slow down the energy transition, and I think no one can afford that. So I think we have a common goal to thrive too. So major bottlenecks that we see, apart from, let's say, EV uptake and prices, which I'm going to put aside for a second because it's more of a supply side issue, but from the, let's say, EV grid integration point of view, let's say, connecting to the electricity grids is clearly one of the main bottlenecks that we see. The challenges are twofold. I always like to subsume them in two boxes. It's planning and pricing. The planning part is, I think we're mostly aware of. We need to plan for the grids to be upgraded where needed, but also not to be overly invested in the sense that we create more cost where we don't need to. So the more we know about the demand of EVs that are going to be connected in 5, 10, 15 years, the better we can scale the grids. And that's the whole planning challenge, because the energy and the transport sector need to work together on all levels. And they need to start by speaking a common language. And the second challenge is pricing. And I'm happy to go further into that in the discussion. But that's really where all the optimization starts. If, as a user, as a, let's say, EV user, fleet owner, I don't get a signal of when is actually the best time to charge, I simply don't have any incentive to do so. Hence, I'm not going to care about saving costs for myself or the system or the environment. Because if I have a flat tariff, it's a flat tariff. But as soon as we get better signals to the end customers of when is the best time to charge, and perhaps one day in the future where is the best time to charge, because you can do that locationally as well, then we create the basic conditions for all the optimization that we can then put into place. That's, can be done by aggregators, it can be done by utilities as well, it can be done by the user, and they should be aware of what's happening and be able to set their preferences. But and that's where it's interesting to look into compare markets, and I'm not going to be too long, but it's really interesting to see that there's already smart charging happening and available in other European markets, in Scandinavia, in the Baltics actually, which are very well used to dynamic tariffs, in the UK. Other places in Europe are catching up, Netherlands, and happy to discuss how we can move that forward in Western, Central, and in Eastern Europe as well. But we have a study in the making That's updating one that we did a couple of years ago, and we saw that those tariffs for smart charging, which is usually a flexibility tariff and a service around it, have doubled in a couple of years. So that's good news. This market is actually growing. Now, let's make it available to all consumers. Let's educate them about what's there on offer so they get interested in saving money. Just as a little final anecdote, I have in my EU team, we're spread sort of across all Europe, and I regularly get these messages from my colleagues who are living in countries where that's already much more available, and they are used to, for example, seeing negative prices, and you know, I get these messages saying, oh, how cool, you know, I charged my car during, you know, a solar peak during midday today, and I made, you know, £10 with it. You know, that's great, but why can I, living in another European country, not access the same benefit of smart charging, although actually the renewable energy is as cheap as it is in another country?
Thank you. And in France, we have also signals, maybe not dynamic, but we used to have signals, and through tariffs as well. Glenn, do you have some comments about challenges, solutions?
But where to start? No. I mean, in every challenge is an opportunity, but we can go beyond that. I have the pleasure to have kind of the connection between the engineers, the government side, the public relations side, and also with Char the privilege of being able to, though my work is primarily Europe, also to have a global view and kind of see where dynamics like the battle of the standards, the connectors, and so on and so forth. I shouldn't be calling it battle, but you know what I mean. So maybe just to hone in a little bit on the European Union, and some of you might have heard me say this already. E-mobility, with the whole change that it brings, the whole paradigm shift, is not only a challenge at engineering or a social level, but obviously at political level as well. And it's a tough job. And you've seen the European Union do something for a sector that it does very rarely. Actually, can't even think of another sector, maybe one of you can, is that they have dictated exactly what targets should be pursued by industry. Before it was more, generally the policy areas I worked in previously was more of a reactionary element to where industry is going. Now you have the European Union, especially the former or still in power European Commission, who put forward a very strong and detailed set of obligations, so to say, not least AFIR and so on. This has put industry, and this is where industry can certainly applaud itself, in a position where they had to come together and sit together. And I sit in some of these groupings within the Sustainable Transport Forum, for example, of the European Commission, where one is about governance and standards and looking about what PKI system should be determined, what data points should be exchanged. These are very active discussions. And many of you might be curious as well to understand a little bit better how the dynamics between the different actors work. But in any case, what has been highly achievable and evident is that you see the technological solutions, even though, okay, bidirectional charging, good to have, is it necessary? Some people say yes, some people say it's a definite must. And how do you solve this, especially when you mentioned about grid capacities, grid integration? I mean, we can go to grid codes and the problems that are prevalent there and the fears that come if there's a blackout. Are the EVs going to be the first ones to suffer? But what about the ambulances? And so on and so on. The list is very, very, very long. But in any case, I mean, I could discuss with you now as well about, I look forward to doing that, also on the global level, when you look about countries like in Brazil, where actually there's not a real legal standard, but there are different standards on the market. It's 95% CCS, for example, and there are a couple of NACs, there are a couple of GPTs, a couple of CHAdeMOs running around, but the standardization bodies haven't given their de facto approval, and you haven't got a law that's in place to say, hey, you know what, this is the standard that should be a minimum, like we have in Europe, CCS2, for example. So bottlenecks at the political level. Of course, we're now facing a lot of dynamics with the new European Commission, the new European Parliament. Of course, we're in a moment where it's no longer about principles and about legal obligations, but now about what needs to be done to implement it. So we're talking here about delegated acts, ISO 15118-2, ISO 15118-20. Are they going to be mandated? By when are they going to be mandated? They're supposed to be coming out soon, but they've been saying that for a while. And soon they'll be available for commenting, but you know, a different kind of instrument at the legislative level. But then I want to come to the third part, general population, the uptake, as we have in Germany, because I'm half German, Bild-Zeitung, who says, oh, grandma stranded at the highway because her car didn't work at the charging station, kind of silly stories, which put a lot of times kind of foot into the system, or a spanner into the works, as they say in English, or in American English as well. But here is exactly where we need to also pay attention, where we need to look beyond what the technological solutions are, and this is also part of my job to kind of say, hey, you know what, and Charan's job generally as well, to highlight, hey, you know, these are the tools, these are the ways to look forward. Just to give maybe an example, there's been a decrease, and we talked about this earlier, there's been a decrease in the uptake of electric vehicles in Germany and the Netherlands. And then you mentioned, yeah, but there is no funding mechanism for people to, well, voila. But this shows the consumer is not able to be a standalone entity to guarantee the rollout of e-mobility that we want to see. And I think I'll conclude for enough on that point and pass on the mic, so to say.
Yeah, thank you. Louis, Julia talked about smart charging. Yeah, you can take the microphone. Yeah. How your company is dealing with this topic, and how do you prepare your customers to it, and all the ecosystem as a CPO?
So first, maybe so Total Energy is, I am leading the innovation for the CPO branch of Total Energy. Total Energy is currently operating 60,000 charge points across Europe, and the target in 2030 will be to deliver 3.5 terawatt-hour of energy to light vehicles and trucks, with 1,700 EV hubs locations across Europe, and more than 300,000 charge points. So we have a big ambition, and smart charging for sure is part of our solution. Today we are, let's say, if I start with the past, so we were obligated to do load balancing with our B2B customers, because you come to your customer, he has a grid connection, right? You have to do with it. So you need to balance the load between the 2, 3, 4 charge points you will install. So that was the first step, I would say. Then we have big networks in Paris, in Holland, we call it B2G, business to government, so street public, public charge points that are on the street. And we are, Netherlands, they have demonstrated that it was possible to steer charging and to shift the load during the night, so to play on the day-ahead market. That was quite a big and large-scale impressive demonstration that were done there. Also to resell on the GoPax market, which is more a congestion market, I would say. We have achieved also in Anvers in Belgium some good demonstrations with load shifting also, so to off-peak hours, I would say, and as well in Paris, where we were able to shed more than 1 megawatt and to kind of sell it on the NEBEF. So we are there, and now the truck industry also is coming, and we have currently we are installing and operating chargers with smart charging that was sold to a customer. So we will have to operate this smart charging. So we were starting to have quite impressive large-scale demonstrations.
Yeah, thank you so much. Nicolas, same for you. Same question. What do you do about smart charging?
What are we doing? So smart charging, for sure, it's something very important for us, but it's probably not the first priority. Our first priority is to sell EVs. And as you said, the market is very complicated at that stage. It's dropping everywhere on Earth for many reasons, but bad and good reasons anyway. So our first goal is first to support our customers to transition to EVs. And then for helping and supporting them, we need to bring them all the solutions to be able to first to charge. That's the first need. It's vital. We need to help them to charge. And so that's our first priority. So probably very soon after that, we'll come back to smart charge. And it will be a huge effort as well to bring them into these new services. The conditions to have to see a success for such services is, I think you mentioned it, to bring them attractivity to these services. And this is absolutely key. And attractivity means first money. You mentioned it, I think it's absolutely key. Money and simplicity. Charging currently is seen as a difficult task, charging experience, just plugging into a home charger, going to a CPO. It's quite surprising for us that are quite, we have a good knowledge about EV, but for some of our customers, it's still complicated. So imagine bringing them to smart charging, which is not so complicated, but a bit more complicated than just putting a plug into a socket. So we will have to work a lot to explain what is smart charging, explain how simple it is, what are the value for the customer and for the society in terms of money, in terms of CO2, in terms of transition. And we need to bring all the win-win conditions on the table for the customer, for we as OEMs or energy companies. And it's under these conditions that we will manage to transition to EVs and transition to energy, new energy markets, I would say, or new energy business. And for that, we are preparing by going into such initiatives. So I think Mobena is a good example. And to reuse a word from my colleague Damien Pierre with us, there is no secret. Test, and learn, sometimes fail. I think we are still in a phase where we need to remain humble, test, learn, and then we will bring something perfect to the customer once we will be ready. That's absolutely key. And last but not least, we have a huge part of education. We need to explain what it is and explain that it is key for transitioning, explain that it's not complicated, I already mentioned it, but we need to have an education part about these smart charging services to onboard everybody on that. So that's exactly the way we are preparing. So in a short conclusion, test, learn, and then apply.
If I may, because I didn't took the EV driver position, in fact, and I fully agree with you. So what I like to say is that we need indeed simplicity and transparency with our customers. We need to jump in their lifestyle, and I like to say that they shouldn't see that we are smart charging. So they should take the car as usual, and the car is charged. That's it. And every time, today in the 1511.8, we have to add departure time, energy need. So energy need comes from the SOC. But at the end, my belief is that we shouldn't ask this to the customers. We should guess, make a good guess, and that's what we are trying to do. So transparency, simplicity, and a business model which runs for everyone. Yeah.
We often say that we want that the charging experience needs to be a non-event. It's just like we are putting gas into our current IC cars, and we need to reach the same kind of experience, being a non-event. No-brainer. It's not the case.
Yeah,
sorry,
of
I
course.
didn't even.
No, you can. I have a specific question for Ginny.
Okay, then I'll,
yeah, you would like to react on that?
Maybe actually I'd like to make a kind of answer for everything that people have said, because all this has been said was about regulation, about experience, about business model, etc. But you must remember that behind that we have physics. We have the system. And just the problem with electric cars is that they're quite simple, but maybe we will have a lot of them. If you take like Paris, if you take a city, in France, most of apartments are like 3 kilowatts, 6 kilowatts. It's the maximum load. Charging, it's like 7, 10 kilowatts. So like 2, 3 apartments. It means that if 1/3, 40% of apartments in Paris have an electric car in some years, and they are connected to the grid, it would kind of say, let's double the charge of Paris. And we will not be able to double the size of the cables in the streets in these 10 years. So things are a bit complicated from this side. And that's where the smart charging has appeared already in some countries like UK, like Germany. Because, well, we are not able to change everything in so fast. So we need to find this time to make this upscale of the grid. So grid code is already imposing a shift of time of charging, even modulation of the charging power, and so on. Either this will be a grid code and it will be imposed for the customer, or it will be an opportunity, a market opportunity, and that's where things become very interesting. Like for those who know frequency reserves, we're discussing about this just some minutes ago. The primary reserve in Europe, it's 3.2 gigawatts more or less. 3.2 gigawatts, if we take 10 kilowatts each electric vehicle, it means like 300,000 electric vehicles. So all Europe together. It's not that far to have 300,000 electric vehicles. We could remove all primary reserve in Europe just using the electric vehicles. Same thing, we could manage congestion, we could manage the absorption of the PVs, that is another problem for the grid. You have too much power during some times of the day. So all this is a challenge and is an opportunity at the same time. But all of those will need to go together. Regulation, new solutions, and the markets will need to go together with the restrictions, the limitations of the system, the physics of the system, such that we can do this job. So that's one point.
It's just a pathetic, I would say, usage that is fully flexible because of its battery and its high potential.
And very fast.
Yes, indeed. Yes, it's an electric battery. Yeah.
That's very interesting.
Yes. Glenn?
It's a little bit of a different direction, but on the point that you had made, and it's about the experience being, or quite a few of you made, the experience being a non-experience. But there are customers, and especially those that are at the forefront of the electric vehicle consumer revolution, so to say, who are interested not only in driving an EV, but seeing what the energy mix is. And this is a conversation that has been going on more, I have noticed last year, decreased a little bit, but I see it reappearing. And this is something because also the European Commission wanted to enforce this notion of we need to know how much of the energy mix in your car is renewable energy derived. And this is a very complex conversation that will probably appear sooner than later again. But there's a question of what the solution is. I mean, there is the idea now that fine, if it's 100% renewable, it's okay. But what do you go when it comes to bidirectional charging? So this is where I have to say, yes, there is the non-experience, but then there's also the fan base that might want to push for this kind of information to be available, and then there the floodgates would be open.
Again, Julia talked about getting planning, ahead of deployment, of course, so then there will be no bottlenecks, no time losses, and waiting, queue, and so on. You talked previously about AFIR, the Alternative Fuel Infrastructure regulation. I think there are different topics in AFIR. I would like just for the audience to get the high level of it, either for planning on motorways and also about smart charging, or also about maybe plug and charge. I don't remember exactly about standardization, what level is done already in AFIR and where we are. What improvement we expect, because I think there are also other usages such as boats and airplanes, whatever. Next steps.
Okay, I feel I'm called on as the regulatory or policy person. So I can perhaps try to start to give a bit of a picture of where we can locate EV grid integration in the various laws that are already out there and being implemented, and then of course, we just have a new European legislative period started with new initiatives. So that's getting kind of interesting. So stay with me. Try to be as simple as possible.
So you can give also figures. What is the about 60 kilometers, all the quantities? I can,
I'll let you
that's
complement.
fine otherwise.
To be brief, the AFIR, I think, is for us, of course, the sort of one of the crucial enabling regulations, because first of all, it is a regulation. It's the first regulation that sets a pan-European network of public charging stations. And that as such is quite a step forward. It's a regulation, member states have to apply it. Second, it sets out the sort of, let's say, backbone or essential network for public charging. And the idea was really at the time that we set the minimum, so the market for those charging services offered at these stations will start to grow. It has never been the idea that everything should be covered by that law. It's just sort of a beginning first step, and this is really how we see it. It sets objectives for charging infrastructure in terms of density and in terms of capacity. And that is, I think, a very smart way to design, because basically with AFIR, the public charging infrastructure network will develop along with the market. The more battery electric vehicles are on the road, the more capacity will be installed publicly. And also there's density criteria, so we have a sort of minimum distance for charging. I'm not going to get into the figures because they're different for cars and trucks, but I must say, especially for the heavy-duty infrastructure, this regulation is quite ambitious. So it sort of implicitly assumes that the number of electric trucks on European roads will grow quite significantly, and I think that's also what we're seeing. Another interesting feature in AFIR is that it requires all new charging points, public ones of course, to be able to be smart. That means to be able to measure and communicate consumption of electricity happening at that charging point. And that is really a key enabling condition to make smart charging happen. But I really want to stress that it's just an enabling condition, because just because the charging point is smart doesn't mean smart charging actually happens. And that's where we get into the energy market regulation side of things. And we just happen to have concluded a big reform, the energy market reforms end of last year, that are now going to be implemented by member states. And those reforms actually get us one step closer, I would say, to leveraging the potential of all these batteries on wheels, all these, at leveraging the potential of demand-side response from EVs. For example, it lowers the threshold for resources such as EVs to participate in flexibility markets. Before it was higher, now it can basically be an aggregated parking lot of a couple of EVs, which is a good sign, because we need to use the flexibility of all those small-scale assets much better. And I think we have seen plenty of pretty cool demonstration projects today of how that can be made possible. And then the energy market reform also requires much more transparency from grid operators, because of course we want to know what's going on the grids, so we can actually make or allow a market for smart charging services to happen. Basically, if we don't know what's happening on the grids, who uses them, when, at what time, when there's capacity available, for what prices. Aggregators, third parties, that are offering demand response services don't have any chance to build even the product and offer it to the customer. So again, it's not going to happen. We need to have that transparency. And I think the energy market reforms do increase the requirements on grid operators. All of this needs to be implemented by national energy regulators. So this is European guidelines that are going to go to national energy regulators in member states, and then are going to be worked out, on national level. So things are going to look different in every country, which is fair because the markets look different in every country. It also, and of course I need to say that because pricing is one of our favorite topics, the energy market reforms also, let's say, contain helpful language when it comes to encouraging time of use pricing or time varying pricing of networks. And we've heard it from, I think, Schneider Electric in the talk before. We have spot market prices for electricity. We know exactly that, photovoltaic energy or wind energy is very cheap at a certain time when it's available. That's not the problem, because that market is liberalized and we have gone through many reforms to get there. The big issue is actually the signals from the grid. We want to know, when there's capacity, and ideally that signal will be a cheaper price to use grids when there's capacity available. And time varying pricing of networks is still in its infancy. It is available in some countries, not in all. But that's really the sort of missing part of the price signal that we would like to see much stronger. So the consumer gets a much more stronger price signal to flex their consumption. It gets a price signal from when the energy is cheap, but they also get a signal of when the use of the networks is cheap. And all of this together sort of doubles my incentive to smart charge, hence save cost for myself, for the environment and the system. So that is the energy market reforms, just to go back to policy. There's a couple of other also important laws. The one that Glenn just alluded to, the RED III, Renewable Energy Directive, which actually requires member states to work out schemes to show or to increase the share of renewable energy that is used to charge EVs. And perhaps we don't need to get into details of how that can be done or not, but it is there as a requirement. And the other one I would like to mention, because it's really part of sort of that policy framework you asked for, is the EPPD, the Buildings Code, and which requires buildings, residential and non-residential, new and refurbished, to be equipped with charging infrastructure. So that's another, let's say, basic enabling condition. If there's no charging, if there's no cabling or wiring in the building, you're not going to get to install those wall boxes that easily. And there have been long discussions about, what's cheaper at which point in time. We know that putting a cable or even just the ducting is relatively inexpensive. Do it and then put the wall box when it's needed. I think that was an obvious one. The biggest missed opportunity in the building codes is really that it did not, the definition of building did not include commercial depots for trucks. And truck charging at the depot is one of the most interesting cases for smart charging, because you have, think of a depot of 10, 20 electric trucks parked somewhere in the suburbs of Paris to do logistics operations during the day. They're parked overnight, perfect use case for optimizing their charging during the night. We have studied that in a couple of European cities, and we get sort of benefits, obvious economic benefits for those depot owners, for those fleet owners in every case, depending on the cost structure a bit differently. But that's another obvious use case for smart charging. And just because it's not in this, let's say, building codes on European level, it doesn't mean that member states cannot implement these a little bit more ambitiously, which would then also include help, subsidies, support information for depots, truck depots who want to electrify and fit, change electric, allow their fleets to go electric, and get the infrastructure ready to do that.
Yeah, I agree. You have read AFIR, EPBD for pre-cabling the building, so then we will not go back to the building and put again other cables, which we have seen actually maybe 15 years ago about telecoms, fibers and so on. The buildings were equipped with everything and then you just plug and play, so totally agree.
Can I just reflect a little bit what was said? Just very quickly, 2 points. AFIR was based on the facts of the failed AFID, and AFID was seen as not pushing enough. And AFIR was built on the thoughts and also on the thought of consumer angst, meaning that, okay, no price displays, where are the card payment systems at the CPO charging points, rather not the CPO, the charging points, and then also the distance-based infrastructure rollout, 10T, and so on and so forth. But what it gave is also a lot of power to industry to start determining how to interpret the provisions. And one of them is where I would like to clarify, smart charging has been defined in the easiest and simplest way in AFIR to allow for leeway to define it better as a use case. It's seen as essentially controlling the energy flow. That's pretty much the definition. But we're sitting in the STF relevant working groups defining the use case behind smart charging. And that's where we get a little bit into the more nitty-gritty. The only difference there is, of course, these documents are often, are generally based then, or what comes out, obligatory based on national authorities and the expertise of industry. But when it comes to actually scrutinizing them, it's not like AFIR where you have the European Parliament, the Council, getting together and scrutinizing it. But in any case, there is still a way to go before we actually have smart charging defined as what the Commission would see as the use case definition.
Yeah, shall I ask Louis, do you have hubs or stations that are fitted with photovoltaics locally, or it was one of the smart charging
use case?
Use case, yes, that you feed locally straight away from
have
your
R&D
own,
projects with storage system, PVs on PV panels on buildings, right, and charging points on the parking. And we also have the Belly project, which is linked to a PPA, PV PPA, but let's say it's not direct electricity consumption. So that's always a problem, you know, the certificate and the PPA is that it's not that. So I fully agree with the mix. We should know at the end where the energy comes from. I think that's key for the future.
Okay, thank you. So let's talk about preparing the future now. Glenn, if you have to choose 3 top research topics which you need, you know, your department to work on, what would you choose? 3? Jirney, sorry. Yeah, Jirney. Yeah, about R&D. So I swapped both. Sorry about that. Yeah, Jirney.
Well, from my side, I have been always working with the grid on how to help the grid, how make the grid continue to work in spite of everything that has changed these last 30 years. So first it was renewables, now our electric vehicles. We have gone through a change of paradigm on the grid on these years. Today, what I have seen a lot on research, we are more and more implementing power electronics in the grid. So we have converters either providing power through solar, wind, or whatever, either by so high voltage, so HVDC, or when we go to low voltage, it's still not a reality microgrids in a wide implementation, but they may start arriving, particularly if we start having solar transformers, solid-state transformers. So all this power electronics coming to the grid has reduced a lot of the inertia of the grid. And this is a main topic that people are working for some years now. 2019 we had a blackout in UK that was really mostly caused by the reduction of inertia. That if you want to have the report, the technical report of this. There was another one in Australia that was 2022, I think, was mostly caused by reduction of inertia. So he has already published in 2023, June 2023, I think, white paper pointing out the major challenge the grid will face in the next years, and reduction of inertia and integration of power electronics is the largest one. So this is a physical phenomena that is happening, and there are many ways of working with. So synthetic inertia, fast frequency support, all of those kind of things that in the end boils down to, if I have a big variation in consumption of production in my grid, how can I steer that, because it will be reflecting frequency, but with fast solutions. And that's where electric vehicles can be very important. You can have a sub-second response from a converter, from the charging point. And that's not possible from a nuclear power plant. So that's the point. You can have, if you have a large number of electric vehicles, you can cope with this. You can cope with the problems of congestion. So this is the second big problem, but then in the distribution level that appears with the solar, with the electric vehicles. So this is the other point. And it's also known, maybe people have heard about the grid forming mode for power converters. So it's how a converter can participate in creating the frequency of a grid and supporting a grid. So those are some of the points we're working a lot in academia and in companies. Power electronics in the grid, how to control this power electronics in the grid, how to help the grid with this power electronics, in particular from electric vehicles. Electric vehicles, they are fast. Other possibility, many people, Total for instance, working is to put static battery storage in some places of the grid. But again, with a number that's not so large as that of electric vehicles, you can have the same effect. So putting a 100 megawatt battery station in one point of the grid. So if you have a charging station in the highway, you have already something like 10 megawatts. 10 stations in a highway, you have already the same power of that battery station. And quite often we're talking about a service of 30 seconds. So all this means that if there is a need, there is opportunity, an opportunity for making quite a lot of benefit. Those services, they're very well paid, very well remunerated, and quite a lot of them, you receive money by being there, not by the service you provide. If you are connected and you're available to make the support, you already are being remunerated. It means that you could considerably reduce your charging price just by being available to make the support. This can be completely transparent for the user. The customer, the charging station can make this optimization and this participation on those markets. So how to integrate those markets into all those algorithms of the manage is the other point we have been working a lot, and several groups in the world are working a lot on this.
Thank you, Ginny. So still in getting prepared to the future, and also actually even currently, I can imagine the OEMs say, going recently to electrification, and also we talked a lot on plug and charge, on ISO 15118 and all the standardization. What about the skills and education of all your employees? How do you imagine the next generation getting educated to this new, I would say, technological and disruptive, I would say, science?
So it's an interesting question. So I mentioned the word education for our customer. That's key, but we have exactly the same challenge internally.
Even car dealers as well for you guys, because we
engineers,
see
salespeople, everyone in the company. It's a tremendous change for us because we are used for years to work on ICs. It's a tremendous change. So we are in a phase to educate, explain, and prepare the company. And to explain, first we need to prepare the company to transition. And to answer the beginning of your question, we are preparing our future product to be ready for such services. And we have to face a tremendous numbers of complex things. We need to fight against complexity. We need to implement everything about hardware. A car, it's first hardware. Let's avoid to forget that, but it's hardware. We have chargers, onboard chargers. We have cables for data management. We have softwares as well. We have offboard and onboard software and IT capability. So we are preparing all of that. And our most important difficulty is to align all these enablers to be ready at day one to start one service. So we are preparing that. And by preparing that, we are also working on onboarding all the people that has to be with this service on the commercial side, on the marketing side, on the engineering side, customer care side, training side. It's a gigantic task. So we are preparing on that. Not only a question of education, but first just making things happen on our products.
Anyone who can add something on this education and the next generation coming?
Yes, I mean we're talking about the type of knowledge we would need actually to share to advance all this optimization we talked about. And I think I want to make a research request, perhaps adding to to your question. What we see is what's still missing is really data on the benefits, the economic benefits that we can gain from optimized charging, the fleets that we expect to see in a given country, in a given area. And I'm saying economic benefits because it's one thing to talk about, let's say, the win-win-win situation that I've mentioned earlier, and on panels like this, people tend to agree, and that's good. That's a really good starting situation. But actually, to be able to show, let's say, the EV fleet that you expect in, a certain region in France, or Germany, or Netherlands, or the Czech Republic, will save as much in terms of grid investments, will be able to reduce peak load in that particular way, is much more difficult to do. But that's exactly the type of knowledge that we need to produce by making studies to convince, let's say, all the groups that are planning on working on this topic in national administrations, local administrations, that there are these benefits that can be reaped. But of course, it requires to make a number of assumptions, and it's different for every region because prices are different, grid conditions are different, geography, topology is different, the number of cars that we expect is different, and regulation isn't, let's say, very strong on this point. I mean, the electricity market reforms I mentioned earlier also require larger DSOs now to do network development plans in which they're required to forecast in a much more detailed way. What type of charging demand from which type of EVs, smaller and larger, they expect in certain grid areas. But let me give you the example of Germany, where we have 880 DSOs. It may sound weird to French people who are used to basically just one with a couple of more local entities, but in Germany we have just the opposite. We have 888 ESOs, and the regulation, those requirements of basically making those detailed demand projections that we need to really calculate those benefits are only applying to the bigger ones, which are 80 out of 880, which means, in other terms, that 800 slip through this very big loophole in the regulation requiring more, transparency and, detailed planning. And that's quite significant, right? So what do we do in these regions? And this is really where we'd like to have more studies. And I can't close without doing a little bit of publicity on one that we've planned.
1 minute, because then the audience will take.
We actually attempted to do that on a region in France. We've chosen the department of Essonne, which, of course, you know here because it's quite representative. It's semi-urban, urban, rural, and we've tried to look into what are the benefits from optimized charging of a mixed fleet of electric cars and trucks that we expect there for 2040. And we've worked with a consultancy who did the grid modeling on this, and what we could show is that there are actually quite an interesting savings to be done on grid investment costs. We've actually started to work on Enedis projections and then sort of did a rough estimate of what you can estimate with optimized charging. And we could also see that different fleets can help reduce the load curve on a specific day we've chosen, because they can help to reduce peak. For example, smart charging overnight, obvious one, can reduce peak, but also workplace charging during the day. All those people that park their car in the office and then sort of use the time it's parked in the office to shift to afternoon hours or absorb a solar peak. And truck charging, next to highways can really help to reduce peak locally in the system. You need to go local to do these studies, but it's really worth doing because we could show where the benefits are. So I'd like this to be replicated in a lot more regions.
Thank you for this. Somebody can give the floor to the audience. We will take questions. Any questions? Okay then, so we will wrap up because it's the end of the day. I can understand how brave you were actually, and thank you for listening. And hopefully you will take, something from this nice, and really I enjoyed discussing with you guys. And let's move on.
Thank you.
Thank you.
So thank you, everyone. Thank you for the speakers, for the moderators, for the audience here and online, and definitely thank you for the organizing team. Thank you for the partners of Mobena, and of course the organizing team at VEDECOM. See you next event.